Let me tell you a little bit about what we're going to be covering. We're going to start off with making sure that you're doing your PowerShell in a safe environment. So I'm going to show you how to build a Hyper-V test environment using either Windows Server 2008 R2 or Windows Server 2012. For those of you with Windows Server 2008 R2 and want to create your environment graphically, I'm going to take you through the GUI interface of how to do it on Windows Server 2008 R2. For those of you who would like to do it in PowerShell, I'm going to provide you the code to build it with Windows Server 2012 R2, and we're going to minimize our GUI interface with that particular lesson. Next, we're going to take you from where you're at right now. You may be grabbing scripts here and there from the internet. People blog out a lot of information. So do I. We do that so you can consume it. But now you're at the point where you need to start creating your own. We're going to start off with memory management so you know how PowerShell envisions memory and how PowerShell really makes it easy for you. Then we're going to take your scripts and we're going to transform them into functions. And then when we get functions that work together, we're going to create modules and we're going to do advanced parameterization so you can start giving your code that professional appearance. When my students leave my PowerShell classes, I call them PowerShell Rockstars. Here you are going to start making modules like a rockstar. We're going to cover the custom format views and type extensions so you can expand the capabilities of your code and also determine how it's going to be displayed to your users. We'll make public and private module members so you can have information hidden in your module for the module's usage, but not for the user. We're going to cover error handling, and we're going to do it at a very detailed level. We're going to look at WMI and CIM. We're going to cover these technologies and show you how to utilize them inside of your code, as well as doing .NET integration. So if there's .NET objects that you need, you will be able to tap into them. Help files are extremely important to developing professional code. I'm going to show you how to build help files, and then I'm going to give you my code that I use to accelerate the creation of help files. I'm going to show you how to debug your code fast and efficiently so that you can bring your code to market quicker. Next, we're going to move on to objects. You need to work with objects. Teaching my PowerShell classes around the world, I find that people want to work with strings of text. That is not how PowerShell works. We need to work with objects. So we're going to start off very simply, how to build an object, what it is, what are our different components. And then we're going to start making them more and more advanced. We're going to pull data from multiple sources. Then we're going to take a look at how to properly store your objects to disk and how to bring them back. Next, we're going to go into creating methods. This is where you actually create functionality inside of an object that works on its own data. It can actually act on itself. And one of my favorite new topics, PowerShell version 5 classes. We're actually going to build class libraries of objects in the same way we've been developing objects in other programming languages. This is a new exciting feature for PowerShell 5. We're going to take a look at the PowerShell pipeline. I'm going to explain to you how it works. And then I'm going to show you how to design your code to work within the PowerShell pipeline. Your ability to reach out into all the clients in your environment or all the servers in your server farm is extremely important. This is part of automation. I'm going to show you how to tap into each machine one at a time, how to tap into many of them at the same time. We're going to do it with ad hoc connections, PowerShell sessions, and CIM sessions. Next, we're going to address the question of how do I work with PowerShell with my specific product. PowerShell expands itself in one of two ways. Modules is how we're moving forward, but we have a lot of technology still in snap-ins. To learn how to discover how to use a product's modules, we are going to use Windows Server. For those technologies that still use PowerShell snap-ins, we will use the Exchange server and we will perform configurations on both using PowerShell. I do not want you to limit your sources of information to just your environment. I'm going to show you how to grab information from the internet from other providers, whether it's a free provider or one that you subscribe to as a service. You are going to be able to reach out and download different types of information from those providers, and we're going to use it inside of our code. I'm going to give you plenty of examples of how to do that. Automation is not true automation as long as you still have to touch the keyboard. I'm going to show you how to create background jobs and schedule tasks. I'm going to explain the difference between the two so you can decide which one's best for you. And then we need to work on reporting. Your users can be consumers of your PowerShell code, but let's face it, they really don't like the text-based interface. We're going to cover just a little bit of very basic GUI creation. We're going to go over HTML creation. We're even going to make it pretty with a Cascade style sheet. And then one of my favorite ways of reporting my automation to myself, we're going to email it to ourselves. I hope that you enjoyed this class. I have had a lot of fun making it. And as a final little piece of information, in this class, you are going to get 8,500 lines of PowerShell code as part of this class. Every demonstration, every example that I have in here, you will be able to download the source code for, so you'll be able to take it and modify it for your usage. Thank you for your time and enjoy Advanced PowerShell. In this lesson, we're going to take a look at the prerequisites to creating a test environment. Now, I write a lot of PowerShell code, but I'm going to be honest with you, I do not test my code in a production environment until I have thoroughly tested it in a virtualized test environment, or a sandbox if you prefer. There are many different technologies out there that you can create a sandbox in. For example, you can create it in the cloud using Azure. If you're more comfortable with VMware, by all means continue using it. I use Hyper-V, and that's where I'm going to be taking the rest of this course, is setting things up to run a virtual test environment inside of Hyper-V. To get Hyper-V, you need one of these operating systems. If you currently have Windows Server 2008 or 2008 R2, no problem. What I'm going to have in your class notes is a download link for the evaluation copy of Windows Server 2012 R2. Our guest operating systems, the ones that are virtualized, will be on Windows Server 2012 R2, but they work perfectly fine if the host or physical computer is Windows Server 2008. If you do have Windows Server 2008, you will need to build the test environment using the GUI. If you have any of the other operating systems, you can do so through PowerShell. Now, a little note on Hyper-V Server. It is a free download from Microsoft, so there's no activation required. However, it is server core. And to work with that, you're going to have a second machine with Remote Server Administrator Tools, or RSET, installed on it. Again, this is a free download from Microsoft. So it may be best to go ahead and install Windows Server 2012 R2 as the host environment. Here are some of the requirements for the host machine in order for us to build our virtual environment with Hyper-V. First off, a minimum of 4 GB of RAM. Our test environment will only have 2 virtual machines. We are going to have to sacrifice performance for memory, but they will work and they will be functional. I prefer you to have at least 8 GB of RAM because that gives us the ability to have more than just 2 virtual machines if we need them. Also, at least 30 GB of free hard drive space. Now, each one of our virtual machines is only going to consume 10 GB. This will prevent us from filling the hard drive. If you're going to have more than just 2 virtual machines in your test environment, make sure you have appropriate hard drive space for them. You also need a 64-bit processor. Nearly every processor sold today is 64-bit, but I know there's some 32-bit processors still floating around out there. You'll also need these next 2 technologies. Fortunately for us, nearly every 64-bit processor produced since 2008 has these technologies. The first one is hardware-assisted virtualization. This allows us to have fully virtualized environments. In your class notes, I'll provide a link to the Microsoft Hardware-Assisted Virtualization Detection Tool. This free download will tell you if your machine or any other machines in your environment has hardware-assisted virtualization. You will also need Hardware-Enforced Data Execution Prevention, or DEP. What DEP does for you, it prevents malware from storing itself in the portion of memory that's marked only to hold data. There's a portion of memory for data and another portion for executable programs. DEP prevents code stored in the data section of memory from actually being executed. Unfortunately, we don't know if DEP is turned on or not. So, being a PowerShell class, I don't want a single chapter to go by without us actually using some PowerShell. I'm going to switch over to my Hyper-V machine, and I'm going to run this code. This is going to help us determine if dep is turned on or not. We're going to ask for information from the WMI class library called Win32_operating system. We're interested in the value of a property called data execution prevention _support policy. I'm going to go ahead and run this code, and you can see that we have a policy level of 3. Now, what this means is dep is enabled for all of our processes. You want to have a 1, 2, or 3. Now, if you get a 0 back, it's okay. What you'll need to do is shut down the machine, reboot it into its BIOS, and then find where to enable data execution prevention. The problem is, between manufacturers and different models of processors, this setting is in various places in the BIOS. So for whatever machine you have, you'll just have to search through all of them until you find them, make sure it's turned on, and then go ahead and reboot the machine. Your next step will be to go ahead and install Windows Server 2012 R2 if you have not done so already, and also if you do not have any virtualized environment. Again, if you have any of the other operating systems I showed you earlier, you can go ahead and use that. But if not, go ahead and do a normal Windows installation. Now, I do want to point out one thing that you need to be aware of when you're installing Windows Server 2012. Let me jump back over to my Hyper-V machine, and what I'm going to do is bring up a virtual machine that I've paused during a Windows installation. The default installation will be Standard Evaluation Server Core. I want you to make sure you're doing a Standard Evaluation Server with GUI. If you just click through here, you're going to get a Core. It is true we can still use PowerShell and Core, however, we will not have access to the integrated scripting environment, and that's going to be critical for you to do scripting. So make sure you've selected Windows Server 2012 R2 Standard Edition Server with a GUI for your physical host machine, but also when you do the installations of the virtual machines, make sure you choose that as well. So what we've learned in this section is the importance of a test environment. Remember, do not test in your production environment. Very bad things can happen very, very quickly. Also, we learned about the hardware and software requirements to build a test environment. Now, where to go from here? If you're using 2008 or 2008 R2, look at the chapter on how to build the test environment on Windows Server 2008 R2. We'll actually go through a graphical installation of our test environment. If you're on Windows Server 2012 or Windows 8, 8.1, Windows 10, you can go to the section how to build our test environment on Windows Server 2012 R2, which is going to be done strictly through PowerShell. But if you prefer the GUI method, that's fine. Just look at the Windows Server 2008 R2 method, and the steps will be the same. We're going to take a look at how to configure our test environment using Windows Server 2008 R2. To complete this task, we need to make sure that we install Windows Server 2008 R2 on a host that is capable of supporting virtualization. You also need to go to Microsoft and download a copy of Windows Server 2012 R2. We're assuming that you have already completed the installation of Windows Server 2008 R2 on the host machine and are ready to install Hyper-V. This is the server manager for Windows Server 2008 R2. To install Hyper-V, simply click Roles, Add Roles, click Next, and select Hyper-V. Then continue to click Next and finally Install and allow the operating system to reboot. This will take a few minutes, so I've already performed this task. Next, you can open up the Hyper-V Manager. What we're going to do in the Hyper-V Manager is set up our virtual switches, and then we're going to create and connect to our virtual machines. So let's go ahead and set up the virtual switches. Click Virtual Network Manager, and we're going to create a private network. The private network allows us to have virtual machines that only communicate with each other as long as they have IP addresses that are in the same subnet. I'm going to click Add, and we're going to give this a name of PS Test, and then click OK. We now have our virtual network. Next, we're going to create our virtual machines. You may be wondering why we started without using Windows PowerShell. Let me show you. Remember, this is Windows Server 2008 R2. We are going to ask to list all the modules on this machine, and you'll see that there is no Hyper-V module even though Hyper-V is installed. That is because the Hyper-V module is not available until you get to Windows Server 2012. We're going to go ahead and create our new virtual machines by clicking New, click Next, and we're going to give this virtual machine the name of DC1. We'll create two virtual machines, one called DC1 and one called Server 1. I want to store this virtual machine in a location other than the hard drive where the operating system is installed. So we're going to put these on the M drive. I'm going to go ahead and create a new folder. We're going to call it VMs, and that's just where I'm going to put the virtual machines. I'm going to click Next. The starting memory. Depending on the amount of RAM that's inside your machine, you can have various levels of RAM. We're going to go ahead and do a 2048 as the initial memory for this virtual machine. I'm going to go ahead and connect it to our PS test drive. And I'm going to create a new virtual hard disk. For this one, I'm going to say, let's only partition out 20 gigabytes. When it comes to the installation of the operating system, we're going to go ahead and use an ISO file. This is going to be the file that we downloaded from Microsoft. We're going to browse for our ISO file. That is Windows Server 2012. There it is. And again, this is the ISO file that I downloaded from Microsoft. I'm going to click Finish. And then we're going to connect to this virtual machine. I'm going to go ahead and power up the virtual machine. Please take note that I'm going to be pausing the video from time to time because some of these steps, because we are on older equipment here, it does take some time. So you'll see the progress bars jump ahead from time to time, but I assure you, you're not going to miss anything. We can see that a normal boot off of the ISO file has started. I'm going to go ahead and select my language, and I'm going to tell it to install. Here we're going to make sure we select Windows Server 2012 R2 Standard Edition Server with a GUI. Do not take the first option, that is Server Core. For our environment, we need to work with a GUI. Click Next. Accept the license. Do a custom install since this is not an upgrade. Click Next. And allow Windows to continue installation. At this time, I'm going to go ahead and pause the video. Once this process has completed, I'm going to repeat the same steps, but this time I'm going to create a new virtual machine called SVR1. Once you've completed the installation of SVR1, go ahead and resume this video. Both of our virtual machines are now online and are ready to continue the configuration. We're going to go ahead and give an administrator password of capital PA $W0RD. Or whatever password you would like. Just remember whatever password you enter here. I'm now going to switch to Server 1. We're now going to provide the same password for Server 1. To log into these virtual machines, simply use the Control-Alt-Delete button and use your administrator password. Do this for both virtual machines. And once again for Server 1. We're now logging into Server 1. Both Server 1 and DC1 will come up with the initial configuration screen. We're going to go ahead and assign both IP addresses and new names to these virtual machines using the initial configuration. Both computers are going to come up into Server Manager. We're going to use Server Manager to both rename the virtual machines and to also assign them IP addresses. I'm currently on DC1. I'm going to click Local Server. On Ethernet, I'm going to go ahead and assign a static IP address. I'm going to right-click Ethernet, go to Properties, select Internet Protocol version 4, and click Properties. The IP address that I'm going to be using for DC1 is 172.16.10.10, a subnet mask of 255.255.255. There will be no default gateway since this is not going to go to the internet. I'm also going to give a preferred DNS server of 172.16.10.10. We will be configuring DC1 to be a DNS server in a few moments. I'm going to click OK, close, and close the network connections window. Next, let's take a look at the computer name. We're going to click on the computer name, select Change, and name this to DC1. Go ahead and click OK. You will need to perform a reboot operation. I'm going to click OK, and then close, restart. I'm going to go ahead and move on to Server 1 and complete its configuration. Local server, And we're going to repeat the process that we just did on DC1, Ethernet. Go to the properties of the Ethernet adapter. And again, I am currently on server 1. For Internet Protocol version 4, click Properties. The IP address for server 1 will be 172.16.10.20. We'll use the same subnet mask, no default gateway, and the same DNS server of 172.16.10.10. I'm going to click OK and then close. Close network connections. Select the computer name, change. I'm going to give it a name of SVR1. Click OK, OK, close, and restart. All right, let's go to DC1 and configure it to be a domain controller and a DNS server. We are now logged into DC1. We're going to click Add Roles and Features. Next. Select Role-Based or Feature-Based Installation. Click Next. We are going to be managing this virtual machine, DC1. Click Next. The role that we're going to install is Active Directory Domain Services. Go ahead and select Add Features. Click Next, Next, and Next. Go ahead and allow it to restart if necessary. Select Yes, and click Install. Once this installation finishes, then we'll promote this machine to a domain controller. The installation of the Active Directory Domain Controller binaries have completed. You will see the link Promote this server to a domain controller. What a lot of people do is they miss this and they just click Close. It's okay. We can get the promotion started again. Click the notification area and you'll see the link once again, Promote this server to a domain controller. Go ahead and click this now. We're going to add a new force since this is the first domain controller in our force. The root domain will be PowerIT.com. Click Next. We're going to have both the force and domain functionality level at Windows Server 2012 R2. This will be a DNS server. We need to give a DSRM password, so give the password for Directory Services Restore Mode. Do not lose that password. Click Next. I'm going to click Next again. Click Next. I'm going to take the defaults and click Next. Next again. Ignore any warnings you receive here and just click Install. This process will take some time. You will need to go through a reboot of this domain controller before you bring it back online and before you proceed with server 1. I'm going to pause the video now and I will resume it once I log back into the domain controller after its reboot. DC1 has completed its promotion to being a domain controller. I've logged into SVR1. We are ready to make SVR1 a member of PowerIT.com. I'm going to click File Explorer, right mouse click this PC, and go to Properties. I'm going to click Change Settings, Change, and then I'm going to move it to the domain of PowerIT.com and press Enter. I'm going to provide the administrator account and the password for PowerIT.com. I have my welcome screen. I'm going to click OK, OK, close, and restart. Server 1 is now going to go into a restart. This is going to allow it to join to the domain and bring our virtual environment online. The next step that we're going to do once Server 1 has completed its reboot and we log into it, we're going to create a snapshot of both of these virtual machines. The snapshots will allow us to revert the virtual machines back to this pristine state where they are both booted up, they're both logged in, and they are both joined to the same domain. That way, if anything happens to your environment while you're testing with PowerShell, you can instantly revert it back. I'm now on DC1 and I'm getting ready to create my snapshot. One last thing I'm going to do is add Server 1 as a managed server. I'm going to click Find Now. There is Server 1. I'm going to add it in and click OK. What this is going to allow me to do is manage all of my servers from one console. I'm going to click All Servers, and you can see that we are bringing Server 1 online, and in just a few minutes, there it is, Server 1 is online. I'm going to go ahead and minimize my virtual machines and go back to the Hyper-V Manager. With both virtual machines logged on and turned on, I'm going to right mouse click each one. Again, these snapshots will allow me to revert these virtual machines should I have any problems. What we learned is how to install a role on Windows Server 2008 R2. We also learned how to create virtual switches in the Hyper-V Manager, as well as create and configure virtual machines graphically. We also learned how to do the graphical installation of Active Directory and join a member server into the domain. We also learned how to graphically create snapshots using the Hyper-V Manager. You are now ready to start working with PowerShell. In this lesson, we're going to talk about configuring our test environment on Windows Server 2012 or Windows 8. Before beginning, you need to have a host computer running one of these operating systems. All of them will give you access to Hyper-V. I also need you to download the evaluation copy of Windows Server 2012 R2. This is going to be the operating system that we deploy inside of our virtual machines. In your class notes, I have a link to Microsoft where you can download this software. These are the tasks that we're going to execute on our host machine. I'm first going to demonstrate installing Hyper-V via PowerShell on Windows Server 2012. Then we're going to switch machines to a Windows 10 machine to continue on. We are making this switch for performance reasons. When we set up the virtual machines, this process will go much faster on a machine running solid-state drives. So you'll get to see a little bit done on Server 2012 and on Windows 10. The code, however, will work on both. So let's go ahead and get started. We're going to go ahead and remote over to Windows Server 2012 machine. Now, just to show you, I'm going to execute the command get module list available. This command is enumerating all the PowerShell modules currently installed on this machine. What I'm going to show you is that we do not have access to the Hyper-V module until we've actually installed the Hyper-V software, which is what we're about to do. Scrolling up through the list, we can see that Hyper-V is not listed. So we do not have access to the Hyper-V commandlets. We're first going to verify that Hyper-V is not installed by running these two commands. You will find this code in your class notes. It's called install hyperv.ps1. We're going to run the first two lines just to verify that we do not have Hyper-V installed. I'm going to go ahead and run it. And you can see right now at the bottom, the name of the role Hyper-V installed false. It's not there. There are two ways you can do this. You can install by using the command line, add Windows features, name Hyper-V, include all sub-features, include the management tools, and also restart if necessary, which this machine I'm on will go through a double restart. Or, if you prefer, you can use the splatting method so that we do not have to worry about horizontal scrolling when we're displaying our code. I'm going to go ahead and execute these lines by highlighting them and pressing F8. The installation of Hyper-V has begun. Again, this machine is going to go through a double reboot cycle. This is going to take a considerable amount of time. So I'm going to go ahead and stop using this machine, and we're going to switch over to a Windows 10 machine where we can continue on. We've now switched over to a Windows 10 machine to show you that the code that we've been using thus far will work even on the newer versions of Windows. Here we're taking a look at Hyper-V. And as you can see, we do not have any virtual machines currently loaded. So we're going to execute some code to configure this environment for our sandbox, and then we're going to deploy our virtual machines. In your class notes, you'll find two scripts, setup Hyper-V and start VMs. Let's take a look at this code. First off, we need to set up some virtual switches so that our client machines can communicate between each other. Line 2 will set up those switches. This is going to be a private network, meaning that they can only talk to another computer on that virtual switch. Let's go ahead and run this line of code. And if we take a look at Hyper-V and go into the Virtual Switch Manager, we'll see that our virtual switch PS test has been created. The next set of code will make an external adapter for our test network. Now, I did not know which network adapter that you would have that would have an internet connection. So this block of code from 4 to 18 will look at all of your network adapters, and if any one of them has a gateway address, this code will give us the option to use that interface card for our internet connection. I'm going to go ahead and press F8 to run. And we could see that I have one network interface card to choose from. I'm going to do that. And let's take a look at Hyper-V. I can see our external adapter has been created. Next, we're going to take a look at actually making the virtual machines. Two areas that you need to take a look at and modify. First off, the ISO path. This is the path to the ISO file of Windows Server 2012 R2 evaluation copy that I downloaded from Microsoft. It is on my eDrive Media, and yes, this is the name of the actual file. Make sure that you are pointing this to the correct path where you saved your copy. Also, you need to determine where you're going to store the virtual machines. I'm storing mine on my D drive in the VM directory. We are going to make two virtual machines, one named DC and one named Server 1. We're going to configure them to boot from their CD drives with an initial startup memory of 512 megabytes. We're going to pass to them the name that's being passed to them in a for each loop and have them connect up to the PS test network switch. Also, we're going to provide the path where the virtual hard drive will be created and give it an initial size of 10 gigabytes. I'm going to go ahead and select this code, lines 24 through 44, and I'm going to press F8. Our virtual machines are being configured, and they are now ready for us to use. Checking Hyper-V, you can see the two virtual machines have been created. Next, we're going to configure the DV drive to point to the ISO path where our evaluation copy of Windows Server 2012 R2 is stored. We're going to go ahead and highlight this code and run it. And now let's take a look at Hyper-V at one of the settings for our virtual machines, and you can see the DVD drive now has the ISO file. Next up, we're going to configure memory for our virtual machines. If you're on a 4 gigabyte machine, then use 1024 megabytes as the maximum bytes. If you have an 8 gigabit machine, 2048. Anything higher than that, then you can choose what's appropriate. I'm going to choose 4096 megabytes for the upper level of my memory. Selecting lines 53 through 59, I'm going to press F8. And taking a look at one of our virtual machines configurations, we will see the memory has been adjusted with a maximum value of 4096. If you did create an external network adapter and would like to connect it to your virtual machines, you can do that now. I'm going to go ahead and select lines 61 through 65 and press F8. And now taking a look at Hyper-V, I can see that we have both network adapters. It's time for us to start deploying Windows. Select the script startvms.ps1. This will start both of the virtual machines if they're not already started, and it will open connection windows for us. I'm going to press F5 to run this code. Here is DC starting up, and here is SVR1 starting up as well. For both these virtual machines, we're going to do a standard Windows deployment. I'm just going to click Next, Install Now, and I'm going to switch between the two machines so they stay at relatively the same point in their deployment. Very important that we choose Windows Server 2012 R2 Standard Evaluation, and here's the kicker, server with a GUI. We need to do this so that we have access to the PowerShell integrated scripting environment. The default installation for Server 2012 R2 is Server Core. We do not want to deploy a Server Core. We also want to make sure we choose a custom installation and continue taking the defaults. This is now going to be a standard Windows installation. Go ahead and pause the video. Resume the video when you get to the portion of the installation where it is asking you to input passwords. Welcome back. You should be looking at the screen asking for a password for each one of your virtual machines. This is going to be for the local administrator account. We're going to go ahead and provide the password capital PA $$W0RD. You can choose any password you like, but I'm going to be using the same password for everything during this course. Go ahead and provide that password to both of the virtual machines. You'll then come to the login screens. Even though it says press Ctrl-Alt-Delete, that's standard on all Windows machines. You can either press Ctrl-Alt-End, which is the END key, or you can click on the Ctrl-Alt-Delete icon on the toolbar. Go ahead and provide the same password you just used. It may ask you if you'd like to resize your screens. I'm going to go ahead and resize mine to full. I'll have to re-authenticate in. And then go ahead and say no at this prompt. This is because we have an external network adapter. We're going to disable that network adapter in just a minute. I'm going to switch back over to the DC, authenticate in as well, resize the screen to full screen, and then continue to authenticate in. And then I'm going to select no. All right, next up, we're going to go ahead and give the virtual machines their names. Even though we specified in Hyper-V what the names are, when you do a standard Windows installation, you do not get the option to choose the name. Here in Server Manager, I am on DC. In Server Manager, I'm going to click Local Server, and you can see the computer name. Go ahead and click it, select Change, and give it a new computer name of DC, and OK it. It will need to go through a reboot. That's fine. We're going to allow it to go ahead and do that. And restart now. While it's doing that, go ahead and go on to Server 1. Repeat the same process, but this time we're going to provide a computer name of SVR1. And I'm going to allow the reboot. I'm back on DC. I'm going to go ahead and provide the password. And then I'm going to do the same thing on Server 1. The next thing we're going to do is configure the network adapters. We need to provide them with an IP address. We're also going to disable the external network interface card so that it's easier for us to connect SVR1 to DC once DC becomes a domain controller. Right now I'm on SVR1. I'm going to select File Manager, right mouse click Network and go to Properties. And I'm going to change adapter settings. I'm going to disable Ethernet 2. And right mouse click and go to the properties of Ethernet. Select Internet Protocol version 4 and go to Properties. We're going to give SVR1 an IP address of 172.16.10.20. 255.255 is going to be the subnet mask. And then we're going to provide the address for the preferred DNS server of 172.16.10.10. That is going to be the IP address of our domain controller. OK, close, and you can go ahead and close these windows. And let's switch over to DC. Repeating the same procedure, File Explorer, right mouse click Network and go to Properties, change adapter settings. We are going to disable Ethernet 2 and configure the properties of Ethernet. We're going to give an IPv4 address of 172.16.10.10. And then we're going to go ahead and give an IP address of 172.16.10.10 for the DNS server. And you can go ahead and close these windows now. Now that we've completed the network configuration of our virtual machines, we're ready to install our domain controller. In your class notes, you'll see that there is a script called create domain. Go ahead and copy that script into memory. We're about to paste it into the server. Go to your DC virtual machine. Holding down the Shift key, right mouse click the PowerShell icon, and run as administrator. Type ISE. And then you can close the shell environment behind it. Go ahead and open a new script and paste. This script will do two things. First off, it will install the Active Directory domain services role onto this machine. Let's go ahead and do that now. We'll select the code, lines 1 through 9, and press F8. This is installing the binary files so that we can make this machine an Active Directory domain controller. The warning message you see on the screen lets you know that automatic updates are not turned on at this time. That message is expected. We can also see we had an exit code of success and we do not need to reboot. We're ready to continue. Go back to the script and highlight starting with import module ADDS deployment and the entire hash table all the way down to install ADDS force. This hash table will provide PowerShell the information that it needs to create our domain controller. We will be creating a domain called powerit.com. Let's go ahead and run this code. We need to provide an Active Directory safe mode password, so we're going to use our standard password of capital P, lowercase a, $W0RD, and then we're going to confirm it. Installation is now going to continue. Go ahead and pause this video. The domain controller will need to go through a reboot. Once the domain controller comes online, go ahead and log in and restart the video. DC has come back online and is now a domain controller. Our next step is to configure SVR1 as a member server. Go to the SVR1 virtual machine. On SVR1, in the Server Manager, click Local Server. You'll notice that it is in a workgroup. Go ahead and click Workgroup. Select Change, and then select the radio button for domain and type powerit.com and press Enter. This is the window that you want to see. If you get an error message, first try this. On both machines, open up the network adapter configuration. If you disable the external adapter when you open the network properties, enable it and disable the other one. Assign the second adapter that you just re-enabled with the IP address of that machine. What happened when the virtual machine was created? It simply put the network switch on the wrong network interface card. Once that is done, come back to the screen and try again. I'm going to go ahead and enter administrator with our password. Go ahead and click OK, OK, close, and restart. Once this machine has finished rebooting, go to your domain controller. The next step we're going to complete is to add Server 1 to DC's Server Manager. On DC, in Server Manager, select All Servers, and you'll see only DC is currently selected. On the dashboard, select Add Other Servers to Manage. Since this is a very small network, just click Find Now. Select Server 1 and the arrow on the right-hand side of Server 1. Now click OK. You'll see Server Manager is attempting to contact it. Select All Servers, and you'll see Server 1 is currently online. Our next step is to go back to the Hyper-V Manager. We are going to create snapshots. Snapshots will allow us to return to our current environment as it is right now, should anything happen, simply by reverting these virtual machines. I'm going to right mouse click DC and tell it to take a checkpoint. If you are on Server 2008, this will be labeled as a snapshot. They are the same thing. Go ahead and do a checkpoint for Server 1 as well. You can do both of these at the same time. When the checkpoints have finished being created, we will see the checkpoints created. I'm clicking my confirmation, and we are done. Your sandbox is now online and ready for you to practice PowerShell. What we learned in this lesson is how to install a role on Windows Server 2012 R2. We also learned how to create virtual switches and also to create virtual machines and configure them using PowerShell. We also installed an Active Directory domain controller through PowerShell. And then finally, we created snapshots. Remember, it's best to test in the sandbox before you put it into production. In this lesson, we're going to take a look at scope. Scope, simply put, is how PowerShell sees information or how it manages memory. If we were a developer and we created an application, it would ask for memory from the operating system. Once the application is done and closes, as a developer, I would have to make sure that my application released that memory back to the operating system. Otherwise, we get what is called a memory leak. A memory leak is when an application closes but does not release that memory for use in other applications. And then as the application has started and stopped and started and stopped, we lose available memory to the point where the computer will slow down and then eventually crash. Also on the PowerShell front, it's where we can actually see information that we created while using PowerShell. This is how scope works from the PowerShell perspective. First off, when you open up a new instance of PowerShell, this opens up what we'll call the global scope. Now, the global scope is going to contain any information that's generated when PowerShell started. There's the environmental variables, the automatic variables, any functions, any aliases. All that's going to be contained inside the global scope. If I were to open up a second instance of PowerShell, it would have its own unique global scope separated from the first instance of PowerShell. Inside of PowerShell, we're going to run some scripts. So when the script opens up, it opens up as a child of the global scope. So it is contained inside of whatever instance of PowerShell it opened in. And as we create our own PowerShell commandlets, when they run, they open up under their own scope inside of the global scope. So here you can see, even though we have a script and a commandlet running inside of our global scope at the same time, they do not share information between the two of them. If you use functions inside your scripts, it also opens up an additional scope. So you might be thinking, big deal. Well, let me show you where this can become a big deal. Let's say on the global scope, you have a variable called name, and it's set to the string data type of JSON. Inside the function scope, you ask for the value of name, but here's the problem. You did not declare that piece of memory inside of your function scope. So what's going to happen is the function scope is going to ask the script scope, do you have a variable called name? Well, the script scope doesn't. So the script scope will ask the global, do you have a variable called name? And global is going to say, yes, I do. And it's going to pass the value of that variable to the function scope, and that is what is going to be read. Okay, no big deal. Now let's go ahead and reset that function scope so its name variable is currently not declared. Let's also run a second script in the same global scope as our original script. The second script is going to actually write information to the name variable. It's going to set it to the integer of 100. Now remember, previously it was a data type string. Now it's a data type integer. So our original script is going to run, and that same function is going to ask for the value of name, which is now 100. Here's the problem. Whatever that function's doing, it needs a string. You just handed it an integer, and all of a sudden, after months of this script working perfectly fine, it just broke. And now you have to figure out what's going on. The thing is that you haven't changed any of the code. So now we have to try and figure out why this script all of a sudden failed when no changes were made. That's one of the dangers we have with scope. But don't worry, scope is also a good thing for you and I, because we do not have to worry about cleaning up memory. Once we close our script or PowerShell, that memory is released back to the operating system. We're going to take a look at a couple of different scripts so we can better see how scope works inside of PowerShell between the shell and the ISE. And then I'm going to show you one of the dangers of using the ISE when it comes to scope. Here we have a program called Scope1. Now we're running this in the PowerShell ISE. Let me just run through real quick what it's going to do. First off, it's going to write the value of X. You can see that it's actually going to display whatever the current value is. Then it's going to display incrementing X by 10. And we're going to use the assignment operator to actually add 10 to whatever the current value of X is and save it as the new value of X. Then we're going to write out the value of X. And then lines 7 and 8 are just simply line breaks so we can see each time we run this code. I'm going to go ahead and run this code. And you can see the value of X is null. Now remember, when the script ran, it did not have a value of X declared, so it goes to the parent. The parent did not have a value of X, so it's null. We increment it by 10, and then that third line tells us the current value is 10. That's what we expected. Now this is in the ISE. Let's go to the shell. I'm going to open up two shells, one in a blue window and one in a green window. First off, on the blue window, let's go ahead and run get variable. In the green window, I'll also run get variable. This shows the variables currently in memory. Now, what I want you to take note of is obviously they're the same. Even though we're opening different instances of PowerShell, these are the automatic generated variables. What I want you to notice is that neither one of them has a variable called X. So what I'm going to do is I'm going to declare X is equal to 100. And I'm going to put it into memory. And then I'm going to ask for the variables. And now on the blue screen, you can see that we do have a variable called X, and it's set to 100. On the green screen, I'm going to ask for the variables again, and you can see X is not present. Remember, these are two different instances of PowerShell, so they have two different sets of memory. Let's go ahead and run our script in the blue PowerShell window. So we can see now the value of X is 100. We're going to increment it by 10, but wait a second, the value of X is 10? Remember that first time, that first line where we grab the value of X, it's pulling from the global scope because we did not declare a value for X in the script. Since the script doesn't know what X is, it asks the parent. The parent said the value is 100. Okay. Now, when we use that assignment operator, x plus equals 10, we actually created a variable called x inside the script scope or inside the memory that the script uses, and we assigned it a value of 10. Now, when we ask for it, since the script knows about a variable called x in its own scope, it's going to report that value. I'm going to run the code again, and you can see the same thing happen. First, it pulls from the global memory. Now, wait a second. Incrementing x by 10, shouldn't that make it 20? The reason why it did not is when the script finished executing, memory was destroyed. The script scope was destroyed along with that value of x equals to 10. So this is actually a new instance of the variable x is set to 10. And we can keep doing this, and that's what's going to happen. Now, let's switch back to the PowerShell ISE. I would like to show you a little difference in using the ISE for testing versus the shell. The difference comes right here. When we have an assignment operator of plus equals, minus equals, times equals, or divide equals. What happens there is that it takes the current value of the variable, performs the operation, and then resaves the result back into the original variable. I only ran the script once. Let me run it again. I'm going to press F5. And you can see, wait a second, x has a value of 10. We increment it by 10, and now the value is 20. Let's run it again. And you can see each time I run it, we are going to get a greater value. The reason why this is happening is because the global scope and the script scope are actually the same thing inside the PowerShell ISE. Let me show you another example here. I'm going to clear our screen, and I'm going to go to Scope 2. Here in Scope 2, I am actually assigning x a value of null. I'm initializing it so it does not go to the parent. Let's take a look at what the parent currently says x is. It currently says x is 50. So I'm going to go ahead and run it, and you can see we're going to perform all these operations, plus equals, minus equals, times equals, and divide equal, and let's see what actually happens. I'm going to go ahead and clear the screen and run the script. And you can see in the first line where we ask for the value of x, well, it's null. That's what we set it to in line 3. We increment it by 10, and now the value of x is 10. If we decrement by 10, it goes to 0. If we multiply by 10, well, 10 times 0 is going to be 0. And we cannot divide it by 5, so it's going to be 0 once again. We're going to go ahead and run this code again, but I'm going to do two things. First off, I'm going to comment out line number 3 so it does not run. And then I'm going to set a value of x is equal to 15. Now I can see that we have an initial value of x in the global scope. Let's go ahead and run the code. I'm going to run it once, and you can see the final value is 30. I'm going to run it again. Our starting value is 30, now the ending value is 60. So every time I run it, because I am not initializing that variable, because line number 3 has been commented out, we continue to get erroneous data. Whenever we're going to ask for a value of a variable or even use it, it's a good idea inside of our code to go ahead and initialize that value. And now you can see it's running as expected. So what we learned is how PowerShell manages memory for you. This is a good thing. Remember, whenever you close an instance of PowerShell, it will erase the memory that you used and return it back to the operating system. Whenever we want to use memory, it's best for you to initialize it, declare your variables, and if need be, set them to null. That way you don't have to worry about the problem in the ISE when it comes to the assignment operators. I love testing my code in the ISE. It's fast, it's simple, but anytime you have a plus equals, minus equals, times equals, or divide equals, you will have that scoping error. So just to play it safe, go ahead and initialize your variables before you actually ask for the values of those variables. In this lesson, we're going to take a look at some of the reasons why IT professionals go from the command line to scripting. In order to set up this scenario, make sure that you've logged into your virtual environment and go onto server 1. Real quickly, we're going to make an adjustment to the firewall on server 1 to allow these demonstrations to complete. In Server Manager, click Tools, go to Windows Firewall with Advanced Security, right mouse click, Windows Firewall with Advanced Security, and go to Properties. And then on the domain profile, turn it off. We're going to be using remoting that is not PowerShell's remoting, so we're going to turn off the firewall temporarily to allow this to work. In practice, I only use PowerShell remoting, but for simplicity in the exercises we're about to do, I want to make sure that this is turned off. So go ahead and click OK. Now let's take a look at some of the reasons why we go from the command line to the scripting world. Really, the major reason I find is that you've got some type of an activity that A, requires a lot of typing to do, or B, it is very, very complex. Let's take a look at some activities that require a lot of typing. Let's say, for example, you need to get information from an event log. Get event log, log name, system. Give me the newest 500 of instance ID number 11, but only if it's occurred in the last 24 hours. Now you should notice that this line is getting a little bit long, but it works. But all of a sudden, you know what? I also need instance ID 12 and 13 and 14, and only if it's been the last 6 hours. So you can see how that we're going to keep retyping this line. Now the problem is I'm still doing manual operations. I still have to look at this data and analyze it. All right, let's look at another reason why. Let's say you need to get the client's manufacturer and model number from all the machines in your environment. Hey, let's face it, not everybody has a very robust inventory system out there, but we can grab this information. But to do this, particularly if it has to be done on a routine basis, can be tedious. Get CIM instance on the class name Win32 underscore computer system. And we want to do this against multiple computers in our environment. Well, here's another problem. Are we going to type all the names in there? And of course, we're interested in only a select group of information. We're going to take the manufacturer, the model, and PSCustomObject so we know where it came from. Now, assuming you typed everything right, you're going to get your results, but you still have to analyze this data some way, somehow. And let's say all of a sudden, oh, I needed the thermal state as well. Now I got to go back in and add that into the mix. Let's say you need to go out to your servers and check their hard drive sizes on all of your servers to see if you need to do any preventative maintenance on them. We can do that. Get CIM instance on the class name Win32 underscore logical disk. One more thing on the computer names DC and SVR1. Oops, hang on. I can tell you the drive type 2 is a floppy drive and drive type 5 is going to be a DVD drive. Well, you know what? We only want to report information on drive type 3, which is local fixed drive. So we got to go back in here and make an adjustment where the drive type is equal to 3. Okay, now we have that information. But you can see we have to keep typing this every time we want to check, and that's going to be a problem. Another common one that I hear about is when did you last hear from a client on your network? All right, well, we can handle this one as well. I am on the domain controller, so I have access to the Active Directory PowerShell module. So I'm going to say get AD computer, give me everything. And let's see what happens. I only have 2 machines in this environment. I get a lot of noise and nothing there's telling me what I need. So let's go back in and add in a special property called last logon date. Now we have that information, but I still have a lot of noise to go through, so we're going to filter it down just a little bit. We're going to select the properties we're interested in, name and last logon date. And now we can see that information, but I'm still looking at it manually. This is an environment of only 2 machines. I have people who sit in my PowerShell classes with over 300,000 client machines in their environment. You simply cannot do this manually. So we're going to take a look at a problem that we have where we have commands that need to be typed often and analyzed. So here's our scenario. We need to collect performance data from various machines in our environment. So we may not have a set collection of machines. This is going to be a very dynamic thing. We also need to collect different sets of performance information from these machines. So we need a convenient way of choosing this performance data. These are the commands that I have to type in frequently to get the information that I need. We're collecting information on the processors, the physical disks, and also the page faults in memory. We're doing it across all the machines in our environment. And you can see at the end, we have different amounts of sampling we need to do and also at different sample intervals. What we're going to do in the next lesson is we're going to take these commands and we're going to put them into a function in a way that we can very easily grab this information without having to type so much information on the screen. We'll then continue to enhance the code through the next several lessons so that you can see how to make a more professional PowerShell commandlet out of your needs. In this lesson, we're going to take a look at going from PowerShell scripts to PowerShell functions. What a function is simply a name that you're going to give to a large group of code, and all you have to do is call that name and the code's going to run. That is really going to sound close to a script. But there is some differences here because with PowerShell functions, we can actually create our own PowerShell commandlets if we want to. Let's take a look at how PowerShell handles functions, and we're going to look at the PowerShell function provider. PowerShell has different providers that allow you to access different data sources and browse them as if they're part of the file system. In other words, our old MS-DOS file surfing commands, CD, mkdir, all that neat stuff, still works. So let's go ahead and take a look at the function provider on our domain controller. We're going to do a directory listing of our function provider. So we're going to access the function drive, and these are the functions currently in memory. Now we're going to revisit these functions a little bit later on, but let's actually take a look at how we're going to create our own function. First off, let's take a look at some code. Now we can run these commands by typing them at the command line, or we can open up the script. If we do it at the command line, that's a lot of typing and a lot of potential errors. If we do it by running a script, all these are going to run. What if I only wanted to grab hold of processor information? Well, technically speaking, I could highlight this code and then press F8, but I still have to open the script in the ISE, I still have to highlight, and I then have to press F8. That takes some time. So let's put this inside of a function. Creating a function in PowerShell is very easy. First off, we declare our function with the function keyword, and then we provide the name of the function. That is what we are going to use to tell this code to execute. Then whatever code we want to execute with this function, we wrap inside of a script block using curly braces. Let's take a look at how to do that. We're going to take what is now our line 4 and make that into a function. So we're going to use the function keyword, and we're going to call our function get processor info. We are then going to wrap it inside of curly braces. And I like to actually hit tab and move all the code over just one tab so I can better see that it's associated with the function. You might have also noticed that we now have collapsible code. I'm going to go ahead and run our script. Right now it looks like it's running, but it's not running the processor info, only the physical disk and now the memory section. You see, we actually have to call the function in order to use it. But now that I've actually ran the script, take a look at tab completion, get processor info. It is actually in memory and usable. This is really interesting because now I can have multiple pieces of executable code stored in the same file. Let's take a look at this block of code. You can see get processor info is still there, but now take a look here. We've wrapped the other two into their own functions. I'm going to go ahead and save this to a place that's easy for us to get to, which is going to be on our C drive, PS folder, and I'm going to call this code 2 just to make it easier to access. Because what we're going to do now is switch back over to our shell environment. Let's take a look at how PowerShell handles these functions. We're going to go ahead and execute code2.ps1, which was our script that we just saved. When I run it, remember 3 functions were in that script. But when I ask for a directory of the function provider, none of them are there. This has to do with what's called scope. When that script ran, it created the functions, put them into its memory, but when the script ended, its memory was destroyed. So if I wanted to make those functions available to me outside the script, I have to do something called .sourcing. As you can see, when we called up the function drive, we did not have our functions. So just running the script is not going to work. We want to be able to call our functions by their name. That's why we did this. So now we need to take a look at using something called dot sourcing. With dot sourcing, I will call my code, but I'm going to add a dot space in front of my code. And now I'm going to run it. Didn't really look too exciting, did it? Let's do a directory of the function drive. And as I scroll up, there are my functions. Get memory info, get disk info, and get processor info. Let's take a look at it now. Get dash will do mem, and I'm going to tab complete, and there it is, get memory info, and it runs. So now this functionality is available at the global scope level. One thing you need to be aware of though, if you close the instance of PowerShell you were using, and I'm going to reopen it again, and I'm now going to ask for a directory of the function provider, they're not there. We have to dot source them back in. Functions, they're very static. So let's take a look at adding some flexibility to those functions. Here you can see that we've taken our 3 different counter data and we put it into a function, but this time we did something special with it. First off, we called this function getCounterData. We then added the param keyword. The param keyword allows us to provide parameters to our functions. If you remember, PowerShell commandlets have parameters. Well, remember, we're making a PowerShell commandlet here. This is how you create parameters for your function. And these parameters are going to allow us to send information to the function, select options, and provide the user with a way to deliver input into our functions. So let's take a look at how this is going to work. Here we have a parameter. Now it looks like a variable, and guess what? That's what a parameter is. This parameter name is called data. The user is going to provide our parameter with a value of 1, 2, or 3. And based on what they provide, that will determine what string of information is saved in a variable called counter, and that is what will be executed. So what I'm going to do is put this into memory by running it. And then I'm going to call it getCounterData. Notice my tab completion's finishing. I'm going to press space and dash. And the IntelliSense says, hey, you've got a parameter called data. And let's go ahead and provide it a value of 1. And there you go, it runs. getCounterData. Our data parameter will now have a value of 2. And now the physical disk information is being provided to us. Now, this is only one parameter. Let's take a look at our final piece of code for this lesson, code 4. And with code 4, you can see that I've expanded the parameter block. What we have here is a comma-separated list of parameters. So now I'm going to have 3 different parameters: data, max samples, and sample interval. Now, I've also provided default values for 2 of these parameters. So I'm going to run this code in the memory. And now let's try it. getCounterData. My data, we're going to select option number 2. Let's do max samples as well. And we're going to ask for 3. Let's go ahead and run the code. And you can see we're being provided 3 samples at 1 second interval. Since I did not explicitly call sample interval, it's going to use the default value of 1 second. What we can do to show you that max samples default value also works is to call our function. Data will do 1. We're going to leave max samples alone and just press enter. And there it goes, it runs. You can see that to create multiple parameters, you provide the param block multiple comma-separated variables. You can see down here in our actual executable statement how we're using this information. getCounter is our commandlet we're executing. We're using 3 parameters of the getCounter commandlet: counter, max samples, and sample interval. To provide their values, we simply provide the variable that holds the correct value. And that is how you create a commandlet using a function inside of PowerShell. Now again, this is a very simplistic view of how to do this, but it does work. Remember, for it to function right now, you need to use dot sourcing. I do suggest that you also look into creating PowerShell modules which allows you to automatically have your functions available to you. What we've learned in this lesson is that functions allow you to run a lot of code with just one command. Your functions can be as big or as small as what you need them to. The script that holds your functions can hold as many functions as you need. Functions also work in their own scope, meaning that any information that you want out of that function needs to be sent to the PowerShell pipeline before the function exits. Otherwise, you lose that information. We need to dot source functions into memory to keep them available outside of the script. We also learned very basically how to add parameters to our functions. In this lesson, we're going to take a look at parameter validation. Whether you're writing scripts or you're writing functions, you can validate the input that users are providing to the parameters of your commands through parameter validation. Parameter validation allows you to validate data in different ways. For example, we can make sure that the data that's provided is of a certain data type. Maybe it's within a range of numbers, or maybe the length of data, the amount of data provided can only be a certain amount, or maybe even only specific values are allowed. We can do this all through parameter validation. One way of providing parameter validation is to cast our parameters to be of a specific data type. We can cast our parameters to be any type of data that we need. String, integer, Boolean, for example, are just a few of them. Let's take a look at doing some casting of our variables. Here we have a set of code declaring a function called getCounterData. We have three parameters: data, max samples, and sample interval. Let me read this information in the memory. And let me just show you real quick what this code does. It simply retrieves performance information. The data parameter tells us which performance information set we want to use. Max samples tells us how many samples to gather, and sample interval tells us how long to wait between samples. Both max samples and sample interval have a default value. But here's the problem. Maybe we want to make sure that we don't send a string value to max samples because that will cause a problem. To do this, we can employ what's called casting. Keep an eye on the parameter block as we switch the code to. You can see that I'm using the long data type and the integer data type to cast out those variables. They can only hold data of that type. In reality, the error message really doesn't change all that much. But in our code, we can be ensured that max samples will only hold data type long and sample interval will only hold a type integer. Let's take a look at doing actual parameter validation. A help file that I would like you to open up in Show window is Get Help About Functions Advanced Parameters. Let's take a look at that help file. It has a lot of useful tools in it. Get Help About _Fun. And just use your tab completion and tab out until you get to About Functions Advanced Parameters, and we'll throw it in the Show window. So let's tackle a few problems that this can help us with. First off, let's say one of your parameters is mandatory. If this parameter is not populated, your code will crash. Let's take a look at making our parameter mandatory by looking for the mandatory argument in our About Functions Advanced Parameters help file. So I'm just going to click Next until we get down to the mandatory argument. There we are. And I'm going to copy this piece of code into memory. Now remember this code. We're going to see it again in just a minute. As of right now, since our parameter is not mandatory, let's go ahead and execute it. But I'm going to leave the data type parameter off. And look what happens. We get a warning, the value cannot be null. This is not something that's pleasant to look at, and if I'm going to be delivering this code to somebody, I don't want them to have to look at something like this if I can help it. So let's take a look at validation code 3. Here you can see we pasted that code that we copied from the help file and placed it right above our data parameter. This associates the mandatory attribute with data. I'm going to run this in the memory, and I'm going to execute that same line of code again without the data parameter. And look at the difference in the error message. Execution of the script has suspended, and it's telling us, hey, you need to provide a value for data. So I'm going to go ahead and do that and press enter. And execution of the code continues as expected. So that's one of the beauties behind the mandatory parameter. If your code cannot function without a specific parameter being properly populated, then you need to mark it as mandatory. Now the problem here is I only have the values 1, 2, or 3. That's not too descriptive. So let's take a look at another way in which we can do validation. And that is with a validation set. So again, we're going to go back to our help file and we're going to look up the validation set. Validate set. And let's go down to the validate set attribute. Now I'm going to copy this line. Notice we already have the mandatory flag associated with data. So I'm just going to copy this in the memory. And let's go back to our code. I'm going to switch over to validation code 4. With validation code 4, we actually had pasted that validation set in, and then we altered the 3 potential values for processor, disk, and memory. Also, in the code, instead of looking for 1, 2, or 3, we're now looking for processor, disk, or memory. Let me show you the beauty of the validate set. Get counter data, which is our function. I'm going to use the data parameter, and look what we have. The valid values for this particular parameter is now tab completable, and we are good to go. Let's take a look at our max samples and our sample interval, because I know that max samples has to have a value greater than 0, but maybe I also want to limit how many samples I can take. So to do this, we're going to take a look at another validation called validation range. Let's go back to our help file and look for validation range. Validate range. Here's the validate range attribute. I'm going to copy this into memory, and let's go back to our code. I'm going to open a validation code 5, and here you can see we have the validate range already populated for our max samples and our sample interval. Now notice I put the minimum value of at least 1, where the default value from copying it was 0. Let's go ahead and run this code and see what happens. If I say max samples 2, everything executes as expected. If I say max samples 0, we get a message that says the 0 argument is less than the minimum allowed range of 1. Supply an argument that is greater than or equal to 1. Let's go overboard and say 20, which is above the maximum range. We get the same message, except it tells us that we're greater than the maximum value. This allows us to control the inputs that our users are providing into our code and make sure that our code performs as expected. So what we learned in this lesson is how to cast parameters so we can be sure that our parameters contain only the data type that we want to use. We learned how to flag a parameter as mandatory. We do this when our code cannot properly execute unless that specific parameter is properly populated. You can use a validation set. If a parameter has only certain values that will be valid, use a validation set. If you want to limit the range in which a number can be in a parameter, then use a validation range. By exploring that help file, get help, about, functions, advanced parameters, you will see many different types of parameter validation that you can perform to make your code more professional and more robust. In this lesson, we're going to take a look at using child functions inside of your scripts and functions. PowerShell functions allow you to run a group of commands by assigning a name to that group. In other words, instead of typing in 100 lines of code, I could type in one command line and it accesses those 100 lines of code. It also allows you to create PowerShell commandlets using PowerShell. In this lesson, we're going to be taking a look at functions by using them to group code together. Let's take a look at the code that we are going to be starting with. This is our starting code. We have a function called doMath. Now, doMath really is not going to do a lot for us at this time. Really, the idea here is for us to have a very basic piece of code so we can work with child functions or sub-functions if you prefer to call them that. That way you can see how to implement functions without having a lot of complex code. So our starter function simply is called doMath. It has 2 parameters, and all it does is add those 2 numbers together. Very simple. Let's take a look at advancing our code just a little bit. Here you can see we've added a new parameter called operation. We can choose between doing addition, subtraction, multiplication, and also division. Let's go ahead and run this code. Once again, it's called do math. I'm going to provide a number. We'll do 15. The next number will be 3. And for the operation, we are going to tell it to divide. And when we run that code, you can see we get the answer. Now, in all actuality, we could stop here and not really go to functions, but this is very simple code, so we're going to take the extra step of going to a function without a lot of complex code so you could see how easy it actually is. So let's take a look at our next set of code. Here we've created a function called addition. Let me explain a little bit about what the information inside of addition will do for you. First of all, we need to pass information to our function. You see, if we ask to use a variable's value without sending a value into it, that function will start asking outside of its scope. In other words, you could accidentally receive information from another part of PowerShell. So we use a param block to declare parameters for the function. And then, when we're ready to send information back to the calling statement, we send it back using the write output commandlet. Let's take a look at using this code. So here in our function addition, we are going to create two parameters, parameter n1 and parameter n2. Down here you can see we've made a change to our addition operation. What we're saying is this. We are going to declare a variable called data, and it's going to be equal to the function addition. And you can see here is the function addition. We're going to pass it two pieces of information. Addition has a parameter called n1 and n2. And here you can see n1 and n2. We're also assigning our original num values. This information is passed up to the function, and then here we actually add the two values together, and the result of that is returned back through write output. With write output, the value of addition will be saved inside of data. Let's take a look at this code being used. Do math. Our first parameter, num1, will be equal to 1. Our second parameter, num2, will be equal to 4. And our operation will be add. When I run this, we get the value 5 back. So once again, what has happened is that we have used the do math function. We assigned values into both num1 and num2. Those values were the numbers 1 and 4. So num1 contains the value 1, num2 contains the value 4. We also send it the operation of add. Down here is where we call our operation to add. We call the function addition. Addition has two parameters, num1 and num2. So the value of num1, which is 1, is passed to n1. The value of num2, which is 4, is passed to num2. These variables pass their information into the parameter block of addition. Here, they are used to do addition, and the value of 5 in this case is generated. Because we have a write output statement being used, that information is then passed back to addition, which is saved in the variable data. At the bottom of the code, we are using write output to properly send information into the PowerShell pipeline, in this case, the value of data. Let's take a look at the final code. Here in the final code, you can see we have functions for each one of our math operations. The only differences that we've made in each one of these functions is the name of the function has been changed, and the operator has also been changed to match whatever function we want to happen. Scrolling down to our switch block, you can see that we've also changed the script block for the switch statement so that it properly calls the correct function and returns the correct data. So let's go ahead and run this one more time. Do math, num1 is 10, num2 is 1000, and the operation is going to be multiply. When we run it, we get our answer. So our code is functioning correctly. Child functions can also be used when you possibly need to reuse the same block of code over and over and over again. This prevents you from having to write it over and over again. It also makes for easy updating of your script. A few best practices for child functions. pass all required information to the function. That way it does not reach outside of itself in the PowerShell and possibly get erroneous data. Use write output to return information back from the function to the calling statement. Remember, you can only return one piece of information. That piece of information, however, can be an object which can contain a lot of information itself. Make sure you declare the function before calling it, or you may not be able to use the function. And also remember, functions have their own scope. If you generated a piece of information that the rest of your code needs, you need to use write output to send that piece of information out of the function before you exit the function, or that piece of information will forever be lost. What we've learned in this lesson is that functions can be used to create reusable code. You can call them as many times as you need inside of your script or your functions. Use a param block to send information to a function. Use write output to return information from a function. And you can have as many child functions as you need. As you continue to develop your programming skills, you're going to find that child functions are very useful features. This lesson is about how to create a PowerShell module. Now, PowerShell has the ability for you to expand its capabilities by adding your own commandlets, and a module is the easiest way to do that because we can do it with PowerShell. A module will package commands into a single file, and then those commands will be auto-loaded into your PowerShell environment if you save them in the correct location and you save them correctly. We're going to learn how to do all of this in this lesson. First off, let's take a look at where PowerShell modules are stored. By looking at the environmental variable, PS module path, this will show you the valid areas where we can store our PowerShell modules. There is also an area that's for your personal storage, as well as, with PowerShell 4, an additional area to store modules that every user who accesses your computer will be able to auto-load your modules. Let's take a look at the areas where we can save our modules. On the screen right now is a simple PowerShell script that's going to enumerate all the locations where we can store our modules. Let's take a look. The first location is your private storage area. It's located in your Documents folder in a directory that has not yet been created, Windows PowerShell Modules. We will be making that directory with code in just a second. Now with PowerShell 4, the second location, Program Files, Windows PowerShell Modules, is now available with PowerShell 4 and 5. If you store a module here, any user who logs into your computer and then turns on PowerShell will have access to those modules. The third location is used by PowerShell itself, and we do not save our files there. So let's go ahead and create our location. Now, normally this is going to be a manual operation. When IT professionals create this location, a common mistake that is made is when they create the Windows PowerShell directory, they generally put a space between Windows and PowerShell. This will cause your modules to fail to load. Make sure that the directory is Windows PowerShell without any spaces in it whatsoever. Let's go ahead and create this location. Here, we have a set of code that is going to create it for us. Now, I'm also going to create a subfolder inside of modules called My Code. My Code is the name of the module that we are about to create. Because my code is getting very wide, I had to practice a little bit of horizontal space management here. It may be very difficult for you to see, but right here is a backtick. Generally, I resort to a method called splatting, but for simplicity on the screen, I went with the backtick method. The backtick on an American keyboard is above the tab key. It is not the single quote. It is the backtick character. It looks like a single quote, but it's tilting to the upper left. After the backtick, I pressed Enter. What that does is says that any code on the next line will be treated as if it's part of the first line. So in other words, lines 3 and 4 are one single line. So we're going to go ahead and create this location. To show you, in our Documents folder, it is currently empty. I'm going to go ahead and run this code. And I'm going to open up Documents. There's Windows PowerShell, all one word. I'm going to open it up. There's Modules. And I'm going to open up Modules, and there is My Code. And again, this is where we're going to store our module. For each module you create, you need an individual folder inside of the modules directory in order to store your code. Now that we have the folder created, we can go ahead and save our script. When we save it, we need to save it as the same name as the folder that it is saved in. We also need to make sure that we save it as a PowerShell module. Once we do that, we'll open up an instance of PowerShell and we're going to see our commands are available to us. Let's go ahead and look at the module we're about to save. This is a very simple piece of code. We are going to create two commands that are going to be available to us, get BIOS info and get OS info. I know this is not very functional, but remember, we're looking at the procedures to create a module, not actually what the module is going to do. Let's go ahead and save this code in the correct location. File, Save As. We're going to go to Documents, Windows PowerShell, Modules, and we're going to save it inside the My Code folder. Also make sure the capitalization is the same. My Code, and then in the Save As type dropdown, we're going to change to a PowerShell script module, and I'm going to save it. That's it. Let's go ahead and open up a new instance of PowerShell. I'm going to ask get module list available. Scroll all the way to the top of the list. This is where your personal data store is at. You can see that my code has loaded and the commands available to me, get BIOS info and get OS info. Let's go ahead and try them out. Get BIOS, and I'm going to tab complete the rest. You can see it picked up tab completion and it can be executed. No further effort on my part to get access to my commands. All we have to do is create a module, put it in the right place, do it correctly, and it will auto-load into your session. Now, let's add a little bit more of a professional flair to it. We're going to add a module manifest. A module manifest is optional, but it enhances the capabilities that we can provide to our module. The module manifest is going to describe the contents of the module. As you build additional content into your module, you're going to have additional files that it's going to need to reference. The module manifest will allow these additional files to be auto-loaded with your module whenever PowerShell launches. This also allows you to determine different levels of functionality in your module. For example, you may have private functions that you do not want to expose to the user, but have them available for the actual PowerShell commandlets to use. We can do that. You can also set certain requirements that have to be met before your module will load. Let's take a look at adding a module manifest. Modules code 4. This is going to be our code to create our module manifest. I need to provide the path where I can find the actual module code. So what I did is I created a variable and I asked for the location of my user profile, which of course is going to be in this case C drive, users, administrator. I'm saving it in my documents folder, Windows PowerShell, modules, my code, and I'm calling my manifest the same name as my PowerShell module, and I'm giving it an extension of .psd1. I'm feeding that to the path parameter of new module manifest. I'm also adding a few pieces of information. You can see that I'm the author. We have a company name that we're going to add. Here's my description. The root module, of course, is the module that is being enhanced by this module manifest, and we're also going to give it a version number. When I take a look at my code, before I load up the module manifest, what we're going to see is that it has a version number of 0. Let's go ahead and run this portion of the code. I'm now going to test my module manifest. And let me switch to a full screen of the console. We can see the metadata of my particular module. We have our version number, we have our description, and you can see some of the other metadata that I've added into the code. Now, right now, it's not doing a whole lot for us. We can enhance that later on. If I open up PowerShell again, get module, list available, and we scroll to the top of the list, you will see that we are now at version 1. So we actually have versioning control over our modules. Let's try something else. On modules code 5, we're going to enhance this code just slightly. You see, right now, this machine is running PowerShell 4. Here we can see the PowerShell version is 4. we're going to put a requirement down, a PowerShell version 5. We're also going to do a little increment to our module version so we can see that it's taken effect. So let's go ahead and run this code. We're going to type get module, list available, and scroll to the top of the list. And two things to take notice. We're back down to version 0, and we have no exported commands. Remember, we've set a requirement of PowerShell 5. Right now, we only have PowerShell 4. So let's go back to that code. We're going to reset the version requirement down to 4 and increment our module version. We're going to go ahead and run the code again. And now let's open up PowerShell and take a look at the results. Get module, list available, version 1.2, and our commands are back. What we learned in this chapter is real briefly what are modules. If you're going to create a group of commands that are designed to work together, put them in a module. If you're going to create tools for a certain group of users, put them in a module. That makes them very easy for you to keep track of, to update, and to further customize if need be. We also learned how to prep our client machines for our custom modules by creating the correct folder locations. We also took a look at how to create a module manifest. Now, don't forget there is a help file for new module manifest commandlet that will show you how to do even more detailed customization of your PowerShell modules. This lesson is how to make custom formatted views for your PowerShell modules and code. PowerShell determines what you see by using a series of XML files. You see, when we ask for information from PowerShell, there is a lot of information contained inside those objects. We simply do not have enough horizontal real estate on the monitor for you to be able to see all that information. For example, let's take get process and ask for just the first piece of information, the first object. So we see 7 fields, but there's a lot more information hidden inside of that object that we normally do not see. The code that created that output, that format, is saved in a view file. Let's take a look at the PowerShell view files. First off, let's get the data type for get process. I'm just going to run this line of code, and the actual data type, or in other words, the name of the object that get process produces, is called a system diagnostics process. I want to save that in memory. Next, I'm going to go ahead and open up in Notepad the .NET types.format.ps1 XML file. In this file, I'm going to press Control F, paste in that system diagnostics process, and we're going to find it. Almost, but not quite. There it is. Now, if we look through here, we're going to see that this is going to be a table view. And we have to provide our column headers. Each one of these table column headers will give us an individual column. For example, you can see we have handles. It's 7 characters wide, and it's aligned to the right. Going back to our code, let's take a look at get processes output. The first column is handles, and the information is aligned to the right. The next is labeled npm parentheses k, 7 characters wide and aligned to the right once again. Here is that label. Data's aligned to the right. So the table headers are going to describe what each header is going to be. Going down to the next section, after the table headers have been closed, we go to our table row entries. Each one of these table column items is going to describe something. For example, in this case, we're going to actually use the value of the property handle count. So our handles column header is populated by the property handle count for each object. If we look at the next property, our npm property is actually calculated. You can see we're using a script block. What it's doing is says take the value of the current object's npm property and divide it by 1024, and that will be the value placed here. There's a lot that we can do with these formatting files. Now, I do want to point out a few things here. Let's take a look at the last table column headers. There's actually 2. Here's the first one, or should I say the second to the last, and here's the last one. Let's take a look what those equate to. The ID property and the process name property. Taking a look at what they equate to in the table row entries, here you can see the column item is actually the property name ID. Now up here, we gave a width and an alignment, but we did not give the actual column header name. It went ahead and derived the column header name from the property name, which is ID. Also down here, we have process name, the property name being populated for the final property. If we go up to the column headers, you can see something's a little different about this XML code. And what is different is right here. This both opens and closes itself. So in other words, they're not giving it an actual column header or a width. Instead, we're letting the table column item do all the work for us. Now this is a lot of confusing stuff to take a look at. Let's break this down into hopefully something that's going to be a little bit easier for us to read. Here we have custom format code2.xml. This is a template. It contains the information to do one column header and its associated property. Copying and pasting the table column headers and then a table column item will allow you to create your own customized view for your objects. This is the code that we want to create a custom view for. Let me explain what's going on here. We have a function that we're going to call getOSInfo. Now, getOSInfo is simply going to grab information from Win32_operating system. It is going to rename some of the properties and keep the same name for other properties. Here in the function newOSObject, this is just a helper function to create a blank object template to store data. And down here is where we're going to populate it. What I'm going to do is run this into memory, and then I'm going to type getOSInfo. Notice tab completion works, and there is our data. Now we have this in a list view. PowerShell will default to a list view when you present 5 or more property items, and it will default to a table if there's 4 or less. Now what we want to do is not only go to a table view, but I don't think that we need to display every piece of information. We only need 2 critical pieces of information from this object. I still want to keep the code as it is in case I need to use it in the future, but I only need to see 2 pieces of information. In order for us to do that, we are going to create our own custom view. Now again, this custom view is going to allow us to control what properties are going to be displayed by default. We can format the data as we want it to appear. We are going to take a brief look at a couple of options in this video, but there is the help file about format ps1.xml. Go to that help file, and you'll be able to look at information beyond what we can cover in this video. Now, let's take another look at the code we just had. I'm going to do a getOSInfo, and I'm going to pipe it to getMember. What I want you to notice is that I gave this object an actual type name. The way how I did that in my code is this line right here. This assigned a type name to the object before it was returned to the calling statement. So now our object has a type name, just like system diagnostics process that came from the get process. Now we have an object with a name and we can work with this. We're going to prep the view file that we're going to use to format our data. We're going to add our content to our view file. We're then going to save our view file as a format.ps1xml file. Finally, we're going to use the update format data commandlet to load it into memory. This is our custom format code5.xml. Now I've already altered it to save us time in this video. You can see we have the name of our views can be from OSInfo, and the type name is anytime it sees an object of OSInfo, this is the default. We're going to display OS type with a column width of 4. OS type is going to draw from the property name OS type. We also want to display our max processors MS property, but we're going to rename the column header MP-MS. We are going to give it a column width, and let's just go ahead and push it up to 14 here. And then to populate it, we're going to do a script block in which we're going to calculate max processors MS. According to the documentation, this is in kilobytes. We're going to present it in megabytes. And this formatting option is just going to ensure that it is a decimal value. Now that we have the code, let's go ahead and save it. We're going to save it, File, Save As. We're going to save it as all files. We're going to call this file osinfo.format.ps1xml. Now I'm going to go ahead and again run my commandlet, which was get osinfo, and we see we still have the default output. I'm going to execute the update format command, and I'm going to add that format file to memory, and I'm going to run my osinfo commandlet once again and take a look. OS type, looks like we need to add a little space there. Let's go ahead and do that now. Let's go ahead and expand this out to 6. Save the file, reload the code, and now run the commandlet again. Now that looks much better. So you can see that we now have a custom format view for this commandlet, but don't worry, our information is still all there. If you pipe it to select object, property star, you can see that the data is still there. If I open up PowerShell in another session though, I don't even have my commandlet. The reason is that I haven't saved it as a module, and that gives us another opportunity that we can take advantage of. We're going to go ahead and create a module out of our code. We're going to create a module manifest. Now this module manifest will specify to load our custom view. Then we'll open up PowerShell, and not only will that module be auto-loaded, but our view will also be in place in memory. We're going to create our PowerShell module by first creating a path to the module so we can make our code a little bit shorter. We're going to save this in module path. We will save this in Windows PowerShell modules. OS module is going to be the name of our module. Here we are in the File Explorer, and we are already in the OS module location. We're going to copy our original code containing the get osinfo commandlet and save it in that path to the file osmodule.psm1 to make it a module. There's our module. Next, we're going to copy our format file over to our module and call it osmodule.format.ps1xml. And it's copied. Finally, we're going to create a new module manifest. And the key thing here is the formats to process. We are specifying the module's view file, and the manifest has been created. Opening up a new instance of PowerShell, let's do a get module list available. Our module has been loaded. I'm going to type get-os and use tab completion and press enter. And there is our data. The object is still preserved, and it's completely available if you ask for it. What we've learned in this lesson is that PowerShell determines what you see through a series of formatting files. They determine the view that will appear from each object on your monitor. We also learned that we can create our own view files. Now these files are very cryptic. Don't forget to look at the help file about_format.ps1xml for more information on how to create them. You can also add your formatted views into a module manifest. That way, when your module loads, it also loads the custom view for any objects that your commandlets will produce. In this lesson, we're going to take a look at creating custom type extensions. Custom type extensions allow you to modify the output of your commandlet without actually going in and changing the code. We're going to be doing this in an XML file. We're going to be adding aliases to our properties. We're going to be able to add additional properties, and we are also going to be able to add methods. And again, this is all going to be done through an XML file as opposed to modifying the original code. Let's first take a look at the code that we're going to be modifying. This is our function doAnything. This is a very simple function. It's simply going to output two properties, num1 and num2. I've hard-coded them to be the values 5 and 10. We really don't care what this function does. All we care about is that we have a function with an object in the pipeline that we can use to demonstrate custom types. If you look right here, we are going to give it a type name of fun stuff. So let's go ahead and give this a try. I'm going to change to the directory where this is stored in, and I'm going to go ahead and .source in this code. Now I can type in my function doAnything, and you can see that it has two properties, num1 and num2. Let's pipe our function to getMember so we can see what the object looks like. You can see we have two new properties, num1 and num2. That was created in our code. We're going to add a custom type file. And in this first example, we're going to add what's called a script property. Now, script property allows you to add additional properties based on the information that's already in the object. Sometimes you're going to have an object that has complex properties. In other words, they have properties of themselves. Sometimes you want to display the value of properties that are buried deep inside of your object, but you want to do this at the root of the object so the user doesn't have to dig through them. We can do that with the script property. In the XML file we're going to take a look at, there are two tags that we need to take note of, the name and the getScript block. Also, we're going to gain access to a variable called this. This will represent the current object and it will allow us to reference other parts of it. Let's take a look at a custom type file. This is a look at our custom type file. This is a very, very basic type file. What I would like to draw your attention to first is the first set of name tags. You'll see fun stuff is in there. If you recall, we named our object fun stuff. Next are the members that we are going to add into our output. We are going to add a script property. That script property will have a name called num3. When we ask for it, it's going to do a calculation based on the num1 property plus the num2 property of this object. And you can see how we refer to it using the this variable. This is the same as using $_ or $PSItem when you're working with the PowerShell pipeline. It is a generic variable and it points to the current object you are working with. Let's go ahead and give this a try. Again, we're going to open up PowerShell into the location where we have our information stored. We're going to .source in our function so it's in memory. And let's go ahead and execute the function, do anything. And you can see we have num1 and num2 as our default output. We are now going to run the code update type data, and we're going to prepend it. Prepend it means this file is going to be read before PowerShell's default files for custom types. The path to prepend it will be custom type code2.types.ps1xml. And again, these files will be provided to you as part of this lesson. I'm going to press enter. And now I'm going to execute do anything one more time, and you'll see that we have a new value, num3, which is num1 plus num2. If we pipe do anything to getMember, we can see we have a script property now called num3, and it is actually num1 plus num2 from this particular object. So we've successfully created a custom type file. We can also add aliases to our custom type. What this will do is it'll give an alternate name for a particular property. It will have a name tag of its own and will also have a reference member name tag, and this is what we're actually looking at. Here we can see our original custom type file, but what I'm going to do is close the script property we just created so we can focus on the alias property. You can see that we have our name tag. We're going to call this alias property number1. The reference member name is the property of the object that it's going to refer to, which is num1. In other words, number1 will have the same value as num1. Let's give this a try. So again, we're going to go to the location of the hard drive where we have this code stored. We are going to .source in the original function and test it, do anything. It's back to its original format. We're going to update the type data, once again prepending it. And this time we are going to use custom code 3. I'm going to run do anything one more time. And you can see we now have a new property called number1, and it is equal to the value of whatever num1 is. If we pipe this to getMember, we will see that we have an alias property available to us, and it is assigned the value of the object's num1. So we've successfully created an alias. Next, we're going to take a look at creating a script method. A script method allows us to do calculations if we need to. Two tags to take note of: the name tag, which will be the name of the method, and script, which will be where we contain the actual script we want to run. And again, this is all going to be done through XML files. Custom type 4. We're going to go ahead and close the original script property num3. Our alias property has already been closed, and we're going to be looking at the script method. Inside the script method, we have a name called add numbers. What this method will do is change the value of the num1 property. The new value will be whatever the current value is plus whatever number we provide when we call this method. Let's give this a try. Once again, we are going to browse to location of the hard drive where the code's at. We will .source it in. We will test to make sure that it's still in its original format. And now we're going to update the type name, prepending it with custom type 4 code. And now we're going to run do anything. We can see that our properties are there. We're going to pipe it to get member, and now we can see the script method of add numbers. Let's go ahead and try this out. We're going to set data equal to do anything. Data is now a copy of the object, and it makes it easier for us to tab complete through and get to add numbers. We're going to add the number 50. I'm going to press enter, and remember, a script method acts on the object it is part of. So if I ask for data again, num1 is now 55. Originally, the value was 5. We added 50. But also take a look that num3 also recalculated itself and updated itself. The key to this is args. Args are arguments. We provided a single argument, and we're referring to it right here in index 0. You see, arguments can be multiple values. So let's take a look at custom type code 5. And here we have a new method called add more numbers. Add more numbers actually runs through every single value you provide the arguments. The arguments will be a comma separated list, and it will add it to that value. Let's go ahead and give this one a try. So repeating our process, we are going to go to the hard drive location, .source in the code, and test. We have the original code. We are now going to update the type data, prepending it with custom type 5. We're now going to set the value of data is equal to do anything. And let's see what data contains by piping it to get member. I can now see the add more numbers script method has been added. So we're going to go ahead and call it data.add more numbers. I'm going to add 5, 10, 15, and 20. Remember, these are going to be added to the original value of 5. When I ask for the current values of data, you can see that num1 has been incremented. Let's do it again. $data.add more numbers, and we're going to add 10, 100. And ask for data again, and you can see once again num1 has been updated. So we just added another method without altering the original code. Now, this is really neat, but it took a lot of effort for us to get there. So what we're going to do is we're going to create a module. You see, now that we have a custom type file for our code, we can put it into a module. When the module auto-loads, the type name data will also load with it and become active immediately. So let's go ahead and look at some code that's going to allow us to do this. Custom type code 6.ps1. Let me run through this code and I'll show you what it's going to do. First of all, we're going to set a path. You can see this path is pretty long, so we're going to shorten things up for the rest of the code. What it's going to do is make sure that we have a Windows PowerShell directory in our user profile with a modules directory, and inside that, a custom type directory. This is where all of our code is going to be saved for the module. Here's where we create the directory. Next, we're going to copy our original code to that location, and we're going to rename it as customtype.psm1. Then we're going to take the types.ps1 XML file that we just finished using it, copy it to that location as customtype.types.ps1 XML. And then we're going to create the manifest module. This is the key aspect right here, types to process. This will add in our custom types as part of the auto-loading of this module. Taking a look at that location, here's modules, and you can see we do not have any folders whatsoever inside of it. I'm going to run this code, and now we're going to take a look. Here's custom type. Here is our module. Here is our custom type data, and here is our manifest. Let's go ahead and open up a new instance of PowerShell. Now, before I actually had to browse to the location was stored at. Now I'm just going to type in do anything, and you can see that the custom type file has already loaded. I'm going to say data is equal to do anything. And data.add more numbers is there. 100, 200, 300, press enter, check out data, and it's there. We have successfully loaded up our module with our custom type data automatically. What we've learned in this lesson is how to create a custom type file for our individual objects. We learned how to do a script property, an alias property, and a script method. We also learned how to auto-load our custom type files with our modules so we do not have to use the PowerShell commandlets to manually load those files, and all of our modules will function as expected. This lesson is going to focus on showing you how to create PowerShell modules in which not all the functionality of the module is directly accessible to the user. You see, if we program our module manifest correctly, we can have both public and private members of the module. A public member is going to be any functionality that you create, any commandlet or function that is available for use. It is going to be available for use by both the user, but also by other commands or functions inside of your module or from other modules. This may sound like a great idea to make everything publicly available, but then again, sometimes in the background, you need functionality that you do not want exposed to the user. In that case, we can make them as private members. With private members, the code that you have as part of that module can still call the private data, the private functions, but they're hidden from the user and they're hidden from other commandlets from other modules. Let's take a look at our starting code for this scenario. Here you can see module members code 1. Let me walk you through what this module is going to do. First off, we're going to have two private variables that are only going to be available to the functions that are inside of this module. Function do one thing, we'll just simply write out hello to the screen since that's the value of string 1. Do two things will both access string 1 and write out a second string of information. And then the function do anything will actually execute function do two things. This is module members code 2. It's going to help you set up the PowerShell module that we'll be using. The one thing you need to take note of, if you're storing your code in a location other than C drive /PS directory, make sure you change it there. Go ahead and execute this code. And what it will do for you is it will create the Windows PowerShell modules directories if they do not exist, but it also will create do stuff and create our module. I'm going to go ahead and open up an instance of the shell, and I'm going to run our code. Here we have do one thing, do two things, and do anything. If we ask for all the commands in our module, which we call do stuff, you will see all three of the commands are available. Here in Module Members Code 3, we're going to create a very brief module manifest. What I want to point out to you is this last component right here, functions to export. When you use functions to export, any function that you do not explicitly mention here will become a private member. In other words, they will not be exposed to the end user. I'm going to go ahead and run this code. This code created a module manifest, and now we're going to run it. Let's go ahead and see what commands are available to us. Get command from module do stuff. Now we only have one command. I'm going to take a look at PowerShell's variable drive. Get variable. If you remember, our function had two private variables, string 1 and string 2. They are not displayed. I'm going to go ahead and execute our code, do two things. Remember, do two things accessed string 1. I'm going to check the variable drive one more time, and we can see that those variables are still not available to the user. Even if I explicitly ask for string 1, we do not have it available to us. Let's take a look at Module Members Code 4. Here we're going to export the function doAnything. Now let's take a look at what doAnything does. In our previous example, we had do two things was the only function exposed. We only called a private variable. Here, we're going to have doAnything be the only function that we can use. It's going to call do two things. Do two things is not going to be a public function, so we're going to show an example of how to make a function private. So I'm going to go ahead and execute Module Members Code 4. I'm going to open up a new shell, and let's see what we have. Get command from the module do stuff. And you can see do anything is available to us. So I'm going to go ahead and try it. Do anything. And you can see that it executed It called the private function do two things, which utilized a private variable. What we've learned in this lesson is how to declare private functions in a module. Again, if you're writing code from somebody, you may have a function that several other PowerShell commands need to utilize, but you do not want to expose that function to the user. So, in our module manifest, we use the functions to export parameter to declare what we want the user to have direct access to, and anything else not listed, they will not have access to. This allows you to reuse code without the user seeing it or being able to call it from other functionality. In this lesson, we're going to take a look at how PowerShell handles error handling. Why should you worry about errors? Well, first off, if we give code to our users or to a client, we want to make sure that if a problem happens, our code will exit gracefully. It also gives us an opportunity to potentially write software that will handle the error, fix the problem, and allow your original code to continue execution. This will help to reduce the stress on end users because they will not have to see cryptic error messages. Also, it adds a certain professionalism to your code when you have graceful error messages as opposed to the default cryptic messages. There are several different types of errors that you can come across in PowerShell. First off, there's the syntax error. The syntax error is going to occur when you do not follow the rules of PowerShell syntax. One of the ways that we can detect the syntax error in the PowerShell ISE is through the colorization of the font and other visual cues. Let's take a look at a syntax error. Here in our code, I am going to remove the ending double quote. Watch what happens to both the color of the font after the double quote and also underneath each line of code. You'll see that the color of the font has changed to a crimson color, which is the default color for a string value. Since we left open a double quote, PowerShell is assuming we want to make a string. I'm going to hold the mouse pointer over the squiggly red line, and it's telling me right there the string is missing the terminator double quote. So I'm going to go ahead and add in the double quotes. A logic error is an error when your code is not doing what you think you programmed it to do. Now, one of my college professors told us the computer will do exactly what you tell it to do, even if it's wrong. And in this case, it's wrong. The logic error is one of the hardest errors to find. You have to go through your code step by step and look at the contents of memory in order to find logic errors. The other kind of errors that we can handle are non-terminating errors. Non-terminating errors happen when your script or your commandlet reaches outside of its own scope of memory. Maybe it's trying to get a file on the hard drive. Maybe it's trying to access a web page. Maybe it's trying to talk to a computer or a printer or something that is just not there. That's when we're going to have these types of errors. Let's take a look at an error happening. In this code, I have three servers, DC, bad name, and server 1. Bad name is offline, and therefore we're not going to be able to talk to it. I'm going to go ahead and execute this code, and let's see what happens. Here you can see the error, bad name. Connection to remote server bad name failed with the following error message. WinRM cannot process request. Okay, that is not an error message that I want end users to see. But we can see DC and SVR1 did execute, so execution continued. PowerShell handles errors in 4 different ways. First off, there's stop. With stop, if an error occurs, even if your code could continue executing, it will go ahead and display the error message and stop. Continue is the default setting. With continue, the code will display the error, but if it's able to continue, it will. The setting of silently continue will allow your code to continue, but will not display an error message. And the final one, inquire, will simply suspend execution, then ask you which of the other 3 you want to do for this particular error. I sometimes come across IT professionals in my classes that think that they should go ahead and just set the error action preference to silently continue so they don't have to see the errors. For you and I, errors are a good thing. They tell us that something is not right about our code. They tell us that we need to correct something before we give that code to the client. To handle errors inside of PowerShell, we're going to use the try-catch-finally method. Try-catch-finally allows you to gracefully handle errors. There are 3 sections. The try block. The code that we believe that an error has a potential to occur is placed in the try block. If an error happens in the try block, the catch block will then execute. No error message will be displayed to the user. The catch block will take over. And the third element is completely optional. It's called the finally block. It will run no matter what, if there's an error or not. And this gives you an opportunity to clean up maybe any resources that you need to close down. We're going to take a look at all three of these in action. Here we have error handling code 2. In this scenario, we are actually going to catch the error. Now take notice that the catch block has nothing in it. In our previous example, you saw the error on the screen. In this example, you will not. Now, this is okay, but the problem is we're still not handling the error. We still need to handle the error. So let's take a look at code 3. With code 3, we added a little additional code. This time we're writing a warning message that there's a client offline. Let's go ahead and execute. Here you can see DC and server 1 completed. However, we have a client that's offline. So we know our try catch finally block is executing correctly. Let me show you where it's catching the error. Right here. This parameter of invoke command is saying go outside of the script. That means that a potential error can happen. That's why it's inside the try block. You can see here, this code is inside the try block. We also had to add the error action parameter and set it to a value of stop. This tells PowerShell if an error happens on invoke command, stop execution, and pass it to the catch block. After the catch block has finished, execution continues on if there is any additional code. We did not get a clear message as to which client was offline, so we made a little change to our code here in code 4. We encapsulated everything inside of a for each loop. In the for each loop, instead of calling clients, all three of them here in invoke command, we're going to send them one client name at a time to the variable C. That's going to allow us to cycle through them one at a time. Now, if an error occurs, we will actually be able to write a warning message telling us which client is offline. And there it is. Client bad name is offline. Let's take a look at adding the optional component, which is the finally block. The only code that we have made a change to is right here. I place this here just to show you what it can do. We're going to write in a green font color, done with client, and then the client name. Let's go ahead and execute this and you'll see what's happening. DC executed first, and we're being told I'm done with DC. Then came bad name. Well, an error happened in the try block, so the catch block took over and wrote the warning message. And then the finally block wrote its message. And finally, SBR1 executed in the try block correctly, so the catch block did not execute, but the finally block executed. Again, we can use the finally block to close any resources we need before we move on if you had any open on the remote system. We took a look at how to handle general errors, but we can also handle specific errors. You see, all errors in PowerShell are objects. And if we can actually get the exception name out of the object, then we can write special catch blocks focused on specific errors. Sometimes you're going to have to put in your try block a set of code that contains many commandlets that are piped together. If one or two of those commandlets happen to have the potential to create an error, we need to be able to handle both errors at the same time in the same try block, but we can use multiple catch blocks to be much more specific. Let's take a look at the last error that PowerShell recorded. Error is an automatic variable. It is an array. What is an index 0 is the last error message. There it is. Bad name connecting to remote server, bad name failed. All right, we've got the error message. Let's analyze it. We're going to take a look at the error object. I'm going to pipe it to get member, and we can see its methods and properties. We need to see what the exception is. So I'm going to ask for the exception property. I'm going to ask it to give me its type information with the getType method. And finally, I'm going to ask for the full name of the error message. That is what we are interested in. You see, if we take this message and copy it, now we can use it in a specialized catch block so that we can capture this specific error. This is code 6. Here in code 6, I now have two catch blocks. You can see there is the message that we captured. Now, just for your reference, I included that entire string that we used to capture the specific error message name in the comments section. What we've done is we have a specific error message that will tell us that that particular client is offline. But if any other error message is generated by invoke command, this general error message will be what is displayed. Let's go ahead and run our code. What we can see here is that the warning message associated with the specific error is what executed. We successfully caught our specific error. What we've learned in this lesson is that there are different types of errors. We have our syntax errors, which can be addressed by watching the colors on the ISE and also by holding our mouse over the red error underlines that appear. There are also logic errors. For logic errors, you need to examine the contents of memory so that you can determine why your memory does not contain what you think it should handle and adjust your code appropriately. For non-terminating errors, we can use the try-catch finally blocks. The code that we think can error, we'll put into the try block. Don't forget to add the error action parameter and set it to stop. If an error is detected, the catch block will execute. The finally block is not required, but it will execute no matter if the try block is successful or not. We also learned how to do multiple catch blocks so that we can capture very specific errors and take specific action against those errors. To have good professional code, we need to address our errors so our users do not have to do it for us. We're going to take a look at using the Windows Management Instrumentation Library to expand your capabilities in PowerShell. I call WMI Library the keys to success because of the amount of information that you are going to have access to. Many of our PowerShell commandlets actually pull their information from the WMI library. The PowerShell commandlets just provide a more user-friendly way of doing it for us, the IT professional. With the Windows Management Instrumentation Library, we can pull very intimate information out of the hardware, the software, and even devices connected to our systems. Before we begin, let's talk about a little bit of vocabulary. First off, WMI is divided into namespaces. Namespaces organize the different classes into their functionality. A class tells you what you're going to get. It's going to define the properties and the methods that you're going to recover from WMI. An example of a class would be the fans, the operating system, the hard drives. When you ask for information from a class library, you'll get an instance. In some cases, you'll get multiple instances. For example, if you ask for the BIOS, there's going to be only a single instance of the BIOS. If you ask for the hard drive information, you may get multiple hard drive instances returned. We're going to take a look at a visualization of the WMI library. First off, let's envision the WMI library as a filing cabinet. Each one of the filing cabinet drawers we're going to call a namespace, so you can already see we have an organization starting to form. Let's go ahead and open up one of those drawers and pull out a couple of the classes. Here you can see the class names for the fans, BIOS, and any printers installed on that client machine. If we were to ask for a specific class, we need to be ready for multiple instances to be returned. Now remember, if we asked for the class information for Win32 printer, each instance would have identical information. The properties and methods would be identical, but of course the value of those properties will be unique because in our case right now we have 3 different printers. Let's start taking a look at the WMI commandlets. Now the WMI commandlets are actually depreciated, but we are going to quickly cover them because those of you who are still using PowerShell 2 in your environments will need to utilize the WMI commandlets. The CIM commandlets are not available until PowerShell 3. Taking a look at our code, first let's take a look at all the namespaces in the WMI library that are currently available to you. What you need to understand is that these namespaces may be different depending on what is installed on the client that you're looking at. WMI namespaces, again, may be different. I will tell you that CIM v2 is the default namespace where PowerShell goes to. If the class library you're looking for is inside CIM v2, you do not need to use the namespace parameter. Let's go ahead and look at all the classes that are in the default namespace. As you can see, there are a lot of them. If you are looking for information in the WMI library, your best bet is to go to your favorite search engine and ask how do I, followed by what you want to do with WMI. You may not get an exact answer, but you may get a reference to one of these class libraries, and then you can go in and take a look to see if the information you want is there. Let's take a look at the operating system information on one of our remote clients. You can see that we get only a subset of information from the remote client. However, if we ask for all the information, you will receive a lot. And again, this is going to be information that by default PowerShell won't give you. You need to ask for all of it. If we pipe this information to get member, we can see the member information, which includes properties and methods. This is an object, just like any other PowerShell commandlet will give you an object. Get WMI will also give you an object. Now, if we go back to the data section, we might notice, for example, data execution prevention _ support policy is a value of 3. What does that mean? Well, in order for you to figure this out, you're going to have to do a little research. When you go to the get member information, you see this is a Win32 _ operating system object. If you put Win32 _ operating system into your favorite internet search engine, go to the MSDN result. This is what you're going to receive. We're going to go ahead and take a look at the data execution policy, and we can see that the numbers will tell us what WMI is actually talking about. So you will have to use MSDN to figure out what the information is saying. There is going to be some research involved, but again, the information you're going to get is priceless. The CIM commandlets are what we will be using moving forward. CIM uses a different technology, the Common Information Model, which actually means that we may be able to use these commandlets with non-Windows machines because it's more of an industry standard. Get CIM instance will get objects from the WMI library. Invoke CIM method will allow us to invoke different methods that are part of the WMI library. And get CIM class will allow us to list all the class libraries using the CIM commandlets. Now, when we return information from a CIM instance, we are going to be missing the individual class methods. These are placed in our output by getCIM instance. So if you're using the CIM commandlet, you have to execute the commandlet just slightly different in order to see the methods. Here I can now see the methods. We have a reboot and a shutdown method from Win32 _ operating system. If we return to the documentation and go to the methods section, you'll see we have a reboot and a shutdown method. We're going to go ahead and invoke the shutdown method against a remote machine. Here you can see I have our server 1 and I'm currently logged into it. I'm going to go ahead and execute getCIM instance on the class Win32 _ operating system against the remote computer, but I am piping it to invoke CIM method. The name of the method is going to be reboot. I'm going to go ahead and run that code now, and I can already see that my server has gone into a reboot. We have forced it to reboot with CIM. Remember that all data returned by either getWMIObject or getCIM instance is an object, just like every other object returned from PowerShell, so we can save it in the variables, and we can also send it into the PowerShell pipeline. Let's take a look at grabbing the BIOS information from our remote system. I'm going to go ahead and save it into a variable called BIOS. I will then ask for the value of the variable BIOS. And we can see we have the BIOS information. And I can also explicitly ask it for specific property values. I'm also able to send it into the pipeline. What we're going to do is get the hard drive information from getCIM instance, and then we're going to pipe it to measure object. We are then going to ask for all the free space on the local machine's hard drive. And we can see that a total count of 4 drives will return, and that is the sum of all the free space in bytes. What we've learned in this lesson is that PowerShell versions 1 and 2 will use the WMI commandlets. However, moving forward with PowerShell 3, 4, and 5, you should be using the CIM commandlets. The WMI commandlets are still supported, however, they're depreciated. The WMI library is divided into namespaces. Each one of those namespaces will have class libraries. These class libraries will define what objects you can recover and the information that will be contained inside of those objects. You can ask for the properties of those objects or invoke their methods just like every other object in PowerShell. WMI and CMI will give you an object. In this section, we're going to take a look at .NET. I like calling this Never Reinvent the Wheel. Because .NET gives us access to a lot of code that you do not have to write. Now, this is not a lesson that's going to cover all of .NET. That alone is going to be a very, very long class. This is simply going to be a lesson on how to access some content in .NET using Windows PowerShell. First of all, .NET is primarily used by developers. It's put out by Microsoft, and it gives you access to different elements of the Windows operating system as well as different types of objects. For example, a radio button or a checkbox is actually a .NET object. Now, we can access all these by using PowerShell, and of course, by doing this, it means we do not have to write the code to create these. We can actually use these elements. Let's first take a look at how to get an instance of an object. Now, many methods and properties require an instance of an object before you can actually use it. An instance is a single object. Let's look at some code. First off, you could see that we are creating, through casting of a string .NET object, a variable called A, and we're going to set it to a value of 1, 2, 3. And then when we ask for the value of the variable A, we get 1, 2, 3. And we send it to getMember, we can see that the object type is in fact a system.string object. We can also simply use PowerShell. You see, PowerShell knows that if you provide a string inside single or double quotes, it will provide you with a system.string object. An easier way to see the object type is simply to use the getType method that is associated with each object type. When I run this, I can see that this is a system string object. We also have methods that are available to us. The methods from .NET are just like any other PowerShell method, but what I want to point out are the static methods. A static method will work without an actual object. And when we look at the documentation on MSDN, we're going to look for methods with an S icon. For example, when we look at the math class, we'll see many of its methods are in fact static methods, and we'll take a look at the math class a little bit later on. And when we go to the datetime object and then go down to its methods, we'll notice that that S is not there. We actually have to make sure we create an instance of the object before we ask for those specific methods. Let's take a look at an example. Here I'm casting out a datetime object to a variable called date, and I'm going to ask it to use its addDays method. This should remove 1 day from the current calendar that's produced, but this is going to create an error. That's because we do not actually have an object for it to work with. Now, this method will work. Here we're actually creating the object using one of the constructors. A constructor tells us how to create an object when we're calling it. In this case, the constructor that we're using is the datetime method. One thing to note is that this will first have to create the object before we can call it, which means it's going to error out on the first run. So here's the first run. We have an error. And now the second run, it executes correctly. So when we run getDate and pipe it to getMember, we will see a system.datetime object is created. We can also run the getType method against it. Remember to put it inside a parenthesis so it creates the object first and then runs the getType method. And here you can see we're using the addDays method successfully because we're creating the object before calling that method. Let's take a look at system.math. Now, system.math class is one of my favorite ones because I do not have to program in how to do a cosine or an absolute value or a logarithm. All this is available to me. Notice the S, these are static methods. Let's take a look at how to use these static methods. Now remember, I do not have an instance of the system.math object at this time. So how I'm going to use pi is simply to call system.math, 2 colons, and then execute the pi method. And you can see I have pi. If I wanted the cosine of 5, I just simply run the cosine method, which requires me to provide a value of 5. Here I'm running the powers method. Here I'm going to raise the power of 2 8 times. And 256 is our answer. Now, since the system namespace is loaded by default, you do not need to actually say system.math. You can just say math, and it'll work just fine. Instantiating a class simply means that we're going to create a brand new instance of this object. We can do through casting, which is what I've been doing. But we can also utilize the new object commandlet. With new object, if your constructor requires an argument of some type, then we can use the argumentless parameter of new object to provide that information to create the object. Let's take a look at some code. Here I'm going to use new object to create a new system.string object. The argument that we're going to provide is C. So I'm going to run this code and I'm going to ask for the value, and you can see the value currently contains the letter C. Looking at the MSDN documentation for system.string class, I can see here's the constructor, string. We provided a character, and this initialized a new instance of the string class to the value indicated by a specified pointer to an array. In other words, it gave us the letter C as the value of our object. Here we're going to create a new object of system IO drive info. One of the constructors say, give me the drive letter you want to use. So I'm going to do that. Now, since drive C is already in existence, you can see that it pulls the information from the current drive C on this system. If you want more documentation on how to do this next one with system.string, I provided it in your notes. In this case, we are going to create a new system.string using a constructor where we provide a letter and how many times we want that letter to be repeated. I'm going to go ahead and run this code and ask for the value of variable B. And you can see A was put into the object 5 times. Now, I know this doesn't look too useful, but it is a very simple example of how to use a constructor, because sometimes these constructors will do a lot of the work for you, so you don't have to go back and code for it later. Not all of the namespaces of the .NET class are loaded in memory, and therefore you can't load their objects until you do. You must load these assemblies, as they're called, manually. Let's take a look at an example of how to do that. Here we're going to try and run the random method of Microsoft.VisualBasic.VBMath. This will fail. The reason is that Microsoft.VisualBasic namespace is not loaded into memory. I'm going to use the PowerShell commandlet add type, specify the assembly name parameter, and the namespace we're going to provide is Microsoft.VisualBasic. Now I'm going to run that same command again, and it executes correctly. What we learned in this section is that .NET allows you to access a library of objects, and I mean a very large library of objects. You use .NET when PowerShell does not provide what you need, and you do not want to code for what is already been coded for you through .NET. We took a look at how to use static methods. Those are methods that do not require you to actually have a copy of the object. You can just simply call their functionality. We learned how to instantiate an object, so you know how to use constructors to build your objects from scratch. We also took a look at how to load into memory namespaces that are not automatically loaded by PowerShell. Using .NET, you can greatly expand what you're capable of doing without having to write additional code. In this lesson, we're going to take a look at how you can build help files for both your PowerShell scripts and your functions. PowerShell has an incredibly robust help system. The help files are designed to help you find the correct syntax for executing your code, provide you with examples of how to execute a PowerShell command, and it also has the ability to give you help on individual parameters of that command or script. For you to develop truly professional code, you need to provide a good help file. In my humble opinion, the most powerful command in all of PowerShell is get help. I've been using PowerShell since its pre-release, and even today I cannot effectively leverage PowerShell unless I type get help. There are various levels of help that you can ask for. Just asking for get help on a command will produce a basic file. However, asking for detailed help will give you the basic help file plus help on the parameters. The full help file will give you information on whether the parameters are mandatory, if they're positional, whether you can work with them in the PowerShell pipeline, or if they accept wildcards. Let's take a look at how to ask for help. We're going to take a look at asking for help on the commandlet getDate. Simply asking for help will give us a basic help file. One of the things that I like about the help system is that you can ask for more information. We're going to take a look at the detailed help. A lot more information, but examples. In your help file, you will need to provide examples so that the user of your code knows how to use it properly. We can even ask for help on specific parameters. You will need to provide help information on each and every one of your parameters. This may seem like a daunting project. What we're going to do is take a look at the structure of the help file, and then we're going to actually create one. And in the end, I'm going to show you how I build help files. The requirements to build a PowerShell help file can be found in the help document about comment-based help. A few things to remember. You must properly declare your parameters in your scripts or your functions so that the PowerShell help system can read them. You also need to make sure you spell out all the keywords of the help file correctly, or the help file will break. Also, make sure you position the help file in the correct location in either your script or function. Inside About Comment-Based Help are instructions on where to place the help file. Let's take a look at building a help file step by step. We're going to start off with our code, help file code 1. This is a function called do cool things. Now we have 3 parameters: name, which is a mandatory string value. We have age, which is an integer value that is mandatory and accepts value from the PowerShell pipeline ByPropertyName. And then we also have a string value of phone. Now, this command actually does nothing. What we are interested in is only the declaration of the parameters. This is going to help us build our PowerShell help file. We're going to go ahead and execute this code, and the last line is to ask for the full help file for do cool things. If we take a look at do cool things, you can see that we already have our syntax block created for us by PowerShell. It tells us that this is a required parameter, it is a string value, and it can accept multiple inputs. We have an age that's a mandatory integer value, and then an optional phone string value. If we take a look at the parameters, we know that age is an integer, it is required, positionally it's the number 1, and it will accept information from the PowerShell pipeline. We see name and phone, but there's no help information either on the commandlet or the parameters, and we do not have any examples. Let's look at help code 2. I've positioned the help file here at the beginning of our function. Here we have a synopsis. This is one of our keywords, capital letters. You will find each of those keywords in the help file about comment-based help. Let's go ahead and run this code. Again, the only change to the code is the addition of the help file. Scrolling up to the top, I can see we have a synopsis. Looking at code 3, we have now added a description to our file. Let's take a look at the output. We now have a description. In code 4, we have added the help information for our individual parameters. You can see each one. The syntax for declaring a parameter is to say .parameter, space, and the parameter name that we want to associate this help with. Make sure it matches the name of your parameter. Do not put a $sign in front of it in the help file. Anything after it will be associated as the help for that parameter. You can see we've done this for all 3 of our parameters. Let's go ahead and execute our code. We can see that a help file has been associated with each of our parameters. In code 5, we've added additional code to our help file. In this case, we have added examples. The syntax for an example is simply put .example and then what the user would have typed for this particular example. And then you can put in anything after that that describes what this example does. In some cases, I put small bits of output. Others can be detailed descriptions of what is actually happening. And you notice I've got 2 examples listed here. Let's take a look at this code when it executes. Now we have example 1 and we have example 2. So PowerShell is writing a lot of this information based on the declaration of our parameters in a correctly formatted help file. What I would like to do now is break this help file. I'm going to misspell a keyword by removing the S at the end of synopsis. Let's run it. Now you can see our information has disappeared. There's no synopsis, description. We no longer have help available on our parameters, and we do not have any examples. This is a giveaway that you have a problem with the formatting of your help file. I'm going to add the S back in and run it, and you will see our help file is back. When I write my code, I write code with a lot of parameters. This can become very cumbersome. So I'm including in your class notes my PowerShell commandlet new help file. I'm going to go ahead and run new help file and place it in memory. Here we have the code, do cool things, but you'll notice we do not have a help file yet. Let's go ahead and run new help file. And the source of this help file is going to be our PowerShell commandlet do cool things. It tells you that it has copied the help file to the clipboard. I'm going to paste this help file in the correct location for a help file and a PowerShell function. You can see that it has given me my keywords all spelled correctly. It has created each parameter section for me with the parameters typed in. It has automatically given me 2 examples and a note field. PowerShell cannot determine what your synopsis or description is. It cannot tell what your examples will be or what the help will be for each of your parameters, but this will help you spell out what you need. Then you may be thinking, that won't take much effort. Well, let me show you something. Let's say you are really writing a big PowerShell commandlet. We're going to ask to create a help file on a commandlet that already exists. Set AD user. Now let's open up a blank script and paste the template for the help file for set AD user. You can see here there are a lot of names. We're going to paste in this blank script the template for the help file for set AD user. What you should take note of is all the parameter names that you could have very easily misspelled, along with all the keywords. This would take you some time. By using new help file, you'll be able to create a template for your help files based on the parameters in either a script or a function. You will then be able to paste it into the actual function and then start creating your help file there without having to worry about a misspelling or an incorrect formatting that would cause your help file to break. What we've learned in this lesson is that you need to provide a help file for all your scripts and functions. That way the consumers of your scripts and functions will be able to ask the help file how to execute the code as opposed to having to call you. Use the PowerShell help file about comment-based help to learn how to properly structure and place your help file within your code. The help file is very specific in its structure and syntax. If you put it in the wrong location, it will not work. If you spell something wrong or structure it wrong, it will not work. Use my commandlet new help file to help make generating your help files much easier. We are going to take a look at various techniques that you can use to find and resolve issues with your scripts. The first bug we're going to take a look at is a typo. A typo happens when you break the rules of PowerShell syntax. The syntax is there so that you can clearly define to PowerShell what you want it to do. To find typos, look in the ISE for odd coloring in the font or red underlines that denote errors. Let's take a look at a couple of issues. PowerShell's ISE colorizes its fonts so that you know what they are intended to do. For example, a comment statement will be a dark green and a string will be a dark maroon. If you look at line 6, the entire line is maroon, and that tells me that something's not quite right. At the beginning of line 6, I have an opening double quote. I have not terminated this opening double quote, so I'm going to do so now. The rest of the line has turned back into a colorized statement, so we know the string has been terminated. Let's take a look at line number 9. Under the opening curly brace, you'll see that there is a red underline. I'm going to place my cursor over it, and it tells me that I've unexpectedly placed an open curly brace where it's assuming I need a closing parenthesis for an if statement. Knowing my PowerShell syntax, by applying a closing curly brace after the comparison operation, I can see that the line has been fixed. Something else that you need to take note of is that sometimes the colors are very close together. For example, a light blue color represents a commandlet, whereas a dark blue is a keyword or maybe even a parameter. The difference between these two lines is the usage of a backtick. Backticks are very useful because they allow you to continue a line on the next line. In other words, line 15 and 16 are the same line. You'll notice that line 13, with its name parameter, does not have a darker color to it, so therefore it's considered a separate statement. I'm going to run lines 12 and 13 together, and what we'll see is we not only get service to run, but our intention was to only recover the service that's name is bits. If we continue down, we'll see that -name attempted to execute. The term name is not recognized as the name of a commandlet function or operable script file. If I run line 15 and 16 together, we will get the desired output, which is only to recover the background intelligent transfer service. The next type of issue we're going to take a look at is the logic bug. With a logic bug, you have already written your code, but is either not producing the desired output or it's not running as intended. To resolve this kind of an issue, you need to look at the contents of memory so you can determine what part of your code is not performing as you intended. To do that, we're going to take a look at both the write debug statement and PowerShell breakpoints. Debugging code 2 is where we're going to start. This code is very simple. All it does is executes a function called doStuff. DoStuff will use a variable x that will start at 0 and count to 5. Anytime x is equal to a value that is not 3 or 5, we will get a dash. Once x is equal to 3, we will get the value hello, and once it's equal to 5, we will get the value goodbye. Let's see what this code does. As you can see, we never get the value of goodbye. That is going to be our issue. So to debug something like this, we're going to take a look at using a write debug statement. A write debug statement will only appear if the user asks for it. Our write debug statement will say x is colon and then the value of x so we can see the contents of memory. In order to gain access to the write debug statement, we must first turn on commandlet binding. Commandlet binding is an attribute that allows our functions to operate as if they were compiled commandlets that are written in C# and gives us access to additional features such as the common parameters. You must accompany commandlet binding with a parameter block. Even if you're not using parameters, leave it empty. At the bottom of your screen, I'm going to call up the common parameters. Again, these are what commandlet binding gave us. We are interested in the debug common parameter. Let's go ahead and run this code and see what the result is. With the debug switch turned on, every time we hit a write debug statement, it will execute and give us several options. We can continue to the next write debug statement, which I will do now, and you can see the value of x is incremented 1. We could say yes to all, which says I will not stop at any more debug statements. We can halt a command which exits the script, or we can go into suspend mode. Let's go into suspend mode. In suspend mode, I can see the value of memory, and I also have the opportunity to change the value of memory. I'm going to go ahead and exit my suspend mode and allow the script to continue. And you can see that the script did continue and wrote hello, which would be what we expect if the value of x was equal to 3. Write debug works very well for small scripts. However, when it comes to much larger code, we need to work with a more dynamic method of discovering our errors. To do that, we're going to work with PowerShell breakpoints. PowerShell breakpoints are objects that are placed in memory and execute while you are executing your code. We're going to take a look at creating breakpoints for variables, specific line numbers, commandlets, and then visually doing it in the PowerShell ISE. This is the code we're going to be using to create our PowerShell breakpoints. You can do this at the command line. I've done it here in the script so that you can have it for your notes. The first breakpoint we're going to set will be for the variable x, and it's going to be for read access. For variables, we can break when a variable is read from, written to, or both. We use the set PS breakpoint commandlet to create our breakpoints. Let's take a look at the metadata for our breakpoint. We can see that it is for a variable, for read access, and it is enabled. We'll take a look at disabling this breakpoint later on. I'm going to go ahead and run our original code, which is debugging code 2, and we can see we hit a breakpoint on variable x when it is read from. The current value of x is 0. Well, we're going to set x is equal to 3, exit out, and we can see we hit another breakpoint when x is read from, and there is our hello value. I'm going to go ahead and quit the code so we can continue on. I'm going to disable this breakpoint. When we looked at a breakpoint's properties, it had an ID of 0. So I'm going to run disable PS breakpoint on ID 0, and that will turn it off. The next breakpoint we're going to take a look at is by line number. In order for us to break on a line number, we must do it against an actual saved script. So I'm going to go ahead and put this breakpoint into memory, and let's take a look at its properties. We can see our original breakpoint is currently disabled, which is our intention, and our new one is enabled. On line 10, we will break on this particular script. We're now going to create our first PowerShell breakpoint. We are going to create it using line 7 and the set PS breakpoint commandlet. We're going to do this on the variable x whenever we read from the variable. We can set up breakpoints on variables for read, write, and both read and write access. Let's go ahead and do that now. I can see the breakpoint has been created and it is currently enabled, which means it's going to run. Let's go ahead and try that against our code. I can see that I've hit a breakpoint on variable x, and just like with the other suspend modes, I can sample the value of x and change it if I need to. Exit will allow me to continue on to the next breakpoint. I'm going to type in quit to completely exit the code. Our ID number for this breakpoint was 0, so I'm going to go ahead and disable our breakpoint on ID 0. And let's take a look at creating a breakpoint based on a line number. On line 14, we create a breakpoint on line 10, and we have to do this against a saved script. We can't run it in the ISE unless the script has been saved. I'm going to go ahead and create this breakpoint. And you can see our previous breakpoint has been disabled. It is still in memory in case we need to use it, but right now it is disabled and will not run. The breakpoint that we do have enabled is on line 10 for our script. Let's go ahead and run our code. I'm going to change to the location on the hard drive where it is saved, and I'm going to run it. Because I'm running this in the ISE, you can see that graphically it's showing me that a breakpoint has been hit on line number 10. In the console window, we can see we hit a line breakpoint in our script on line number 10, and again, we can sample the value of memory and manipulate it if we need to. I'm going to exit, and you can see we can continue on to each line if we need to. I will now quit the code, and let's go and disable that breakpoint. Our final breakpoint that we're going to take a look at is a breakpoint when a specific commandlet executes. Here you can see in line 20, we are going to set up a breakpoint for when write output executes. With our breakpoint ready to roll, we're going to go ahead and execute our code. And I can see write output has broken. I can now see the value of memory. X is equal to 0. Now remember, originally we're trying to figure out why our code will not finish. We're looking for the word goodbye to be displayed. So let's just go ahead and allow the code to continue. We're going to exit and continue to look at the value of memory. X is currently 1. We're going to exit, allow it to continue. You can see the dash has appeared because there is a value displayed where X is not equal to either 3 or 5. So we're going to continue and observe the value of X as we step through our code. X is equal to 2. X is equal to 3. We're going to allow it to continue. We see X is equal to 4, so we're going to allow it to continue. And wait a second here. The code's finished. Uh-oh, we never got to the value of 5. So if we take a look at our logic, I can see the problem is right here. We never allow our counter variable to equal to 5. So I'm going to change this from less than to less than or equal to. I'm going to go back in and disable our PowerShell breakpoint. I have a feeling this is going to work. And now I'm going to run the code. And there it is, goodbye. So what we learned in this lesson is how to see typos using PowerShell's ISE colorization. We learned how to use both write debug and PowerShell breakpoints so we can view the content of memory so we can discover why our code is not doing what we intended it to do. In PowerShell, we use objects for everything. Our commandlets produce objects, and we create commandlets ourselves that receive objects through the PowerShell pipeline. This section is on how to create simple objects. The first method we're going to take a look at is using the PowerShell commandlet selectObject. With selectObject, you send it information in the PowerShell pipeline, and then you can modify it by either removing properties that you do not need or adding new properties with a hash table. Let's take a look at some code. Here we're using getProcess. getProcess produces a lot of information. Let's pipe at the get member and take a look at the properties that are produced by getProcess. As you can see, there are a lot of properties. One of the things that we can do with selectObject is use its property parameter to filter out the properties we do not need. This comes in very handy when you're trying to gather data across your network because you're going to be getting a lot of information, but a lot of those properties you may not need. So to conserve network bandwidth, we can use the property parameter filter out only what we need. I'm going to pipe this entire command to get member, and you'll see in the end, we only retained the information that we wanted inside of this object. We can also modify the data that's currently inside the PowerShell pipeline. As you can see, we do have a VM and a WS property. In this example, we're going to keep only the name property, the CPU property, but we're going to be using a hash table to create a brand new property based on information currently in the pipeline. This hash table consists of two parts.
The name section, which will create the property name, you'll see that in the left-hand column when we look at our information in getMember. And then the expression. The expression is where we build the value of that property. You'll see that we're using one of PowerShell's generic variables, $_. $_ represents the current object in the PowerShell pipeline. There is only one object at any one time. In our case, we're going to allow a total of 5 objects. Those of you who've been working more with PowerShell 3 may recognize the generic variable as PSItem. They are the same thing and have no difference in their functionality. The hash table is denoted by the ampersand and then encapsulated in its own set of curly braces. When creating a hash table with select_object, many IT professionals forget that the expression must be inside of its own script block. Let's go ahead and run this code and see what happens. You can see we keep our name property, our CPU property, but there's our VM_WS property, which consists of each individual object's VM and WS values added together. Let's go ahead and pipe this all to getMember, and we will see our new object. And there it is, VM_WS. Now there are many different ways that we can write this particular set of code. Here's an alternate syntax. I first wrote it out in longhand format. What I mean by longhand format, I separated everything on the individual lines to make it easier to see. We can also write it in one continuous line. You can see the only thing that I needed to add was a semicolon between the name and expression lines. These are individual commands. So to put 2 or more individual commands on the same line, we use a semicolon. Our alternate syntax 2 is simply, instead of stating name, we put the letter N. Instead of expression, we put the letter E. This allows us to write in shorthand. And as you can see, the code executes correctly. Next method we're going to take a look at is using newObject. The PowerShell commandlet newObject allows you to have more control over the creation of your object because you can create it from scratch as opposed to using something that's already in the PowerShell pipeline. It also allows you to create a type name for your object. With a type name, you can use formatting files to determine how the output is displayed on the screen. Let's take a look at some code. Here I'm creating my object. I'm using a variable. I just called my variable $OBJ. I set it equal to the PowerShell commandlet newObject. The type name of this object is PSObject. A PSObject is a blank object. We then declare the properties of our object in a hash table. This hash table is a little bit more clean and easier to read. We start with the ampersand and the open curly brace. This must be on the same line as property. We also have a closing curly brace. Now on these 3 lines, we're declaring our properties and their values. Our name property will have a value of null. Our date property will have the current date. And we'll have a city property that is currently set to null. Let's go ahead and take a look at this by placing it in memory. And I'm going to ask for the object. And there you can see we have the date in the format that I asked for, and the name and the city are empty. Once you have the object, you can assign values directly into each one of the properties. Here you see I have $OBJ.name, and I'm assigning it to my name, and the city to Phoenix. I'm going to go ahead and run this code, and then let's view the object. Now you can see the object contains information. This object has members, city, date, and name. We can also assign an object type to it. After running getMember, you can see the type name is System Management Automation PSCustomObject. Well, again, in order for us to assign a data file to it that allows us to format the output, we need to assign a type name. My next line of code assigns a type name. The 0 denotes that the first value I'm sending to the object will be its type name. This is the value that will be the type name. I'm going to go ahead and execute this code. And let's view the object's members one more time. And there you can see the type name has been corrected. Now remember, this object can be used inside of the PowerShell pipeline. I'm simply going to pipe it to select object and say, let's go ahead and expand out the property of city. And when I run it, you can see Phoenix appears. What we've learned in this lesson is how to use select object to take information that we currently have in the pipeline to add new properties into our objects.
We also learned how to use new object to create objects from scratch.
When working with PowerShell, we work with objects. Many times we need to create our own customized objects using information from multiple sources. This section is going to show us how to do that. We use our custom objects when we have information that needs to be presented in one concise package. Remember, we can only send one object to the PowerShell pipeline, so we have information from multiple sources. We need to place all of that information into the same PowerShell object. This also makes our information compatible with the PowerShell pipeline so we can continue to use it. Let's take a look at some code. This is going to be our starting code. You can see that I'm reaching out to two different computers, one named DC and one named SVR1. We're going to talk to each computer one at a time, and we're going to pull information about the operating system and the BIOS from the WMI library. We're going to save all the information from each one of these commands into two different variables, the OS and the BIOS variable. Here you can see that we are making our customized object. We only want to keep the information that we need in our object. So we're going to create three custom properties: caption, OS version, and BIOS serial. Here you can see how we populate them. The caption property is going to be pulled from the operating system information, which contains a caption property. Our OS version is going to come from, again, the operating system information, where it has a version property. Our BIOS serial is going to come from the BIOS information, where there is a BIOS serial number. We use the write output commandlet to properly place our custom object in the PowerShell pipeline. Let's see this at work. And there you can see our custom object. Here I'm going to show you that our object works well with the PowerShell pipeline. We are going to pipe it to our object, and we're going to filter on the caption property for anything that starts with Microsoft. Let's go ahead and take a look at the output. Here you see that we retained both objects because they both started with Microsoft in the caption. They fit our filter, so we're going to keep them. Here I'm showing you compatibility with other commandlets. In this case, we're going to save the output into a variable called data. This will contain what was going out to our screen. Down here on line 18, we're going to pipe it to our grid view so I can show you that we are truly working with an object. I'm going to go ahead and run this code, and there it is in our grid view. Here I'm going to show you where we can pipe our object into select object to create custom properties in our object. In this case, we're going to create a new property called version, and it's going to contain whatever the current object's OS version is, minus a couple of characters. Let's go ahead and take a look at the output. And there you can see our version number retaining only the major and minor versions. In this lesson, we learned how to take information from multiple objects and combine them into a single custom object. This allows us to use the PowerShell pipeline. Since the PowerShell pipeline can only handle one object at a time, if you have information from multiple objects, you need to combine them into one custom object. This also makes your object usable with other PowerShell commandlets so you can continue to use your skill set with the PowerShell pipeline. Many times in PowerShell, you're going to be working with a complex object. This lesson describes what a complex object is and how to properly store and retrieve it from disk. A complex object is any object that has a property that contains more than one value. If an object has a property called number, and that number contains a singular value, for example, the number 1, then it is not a complex object. But let's say it has another property called numbers that contains an array. An array would be a property that has many values, such as 1, 2, and 3. Or it is a property that contains an entire object. With a complex object, we have to be careful how we save it to disk. Let's take a look at using a CSV file. A CSV file stands for comma-separated values. What it means is it's a plain text file, and each value is separated by a comma. Now this only works for two-dimensional data. Three-dimensional data will not store. A CSV file cannot store a property that has more than one value. We're going to take a look at how to identify what properties may contain more than one value and what happens when you save them to a CSV file. Here in our sample code on line number 6, we are going to ask Active Directory to give us the user object for the administrator account. But we're also asking for an extra property to be provided called member of. Member of stores the distinguished names of every group that the administrator is a member of. Let's take a look at the results. Here you can see the user object for the administrator account. What I would like to point out to you is the member of information. In particular, there are two items I want you to take note of, and that is the opening and the closing curly brace that is part of this property. What those curly braces tell you is the member of property has the potential to contain more than one value. When you're looking at the objects that you have in the PowerShell pipeline, you may see a property value that has the opening and closing curly braces, but nothing inside of them. That is still a flag to tell you, hey, I can store more than one piece of information. What we're going to do is we're going to save this information to disk, and we're going to do that on lines 9 and 10. We are first going to save it to a CSV file. Now we're going to recover that information with the import CSV commandlet. What I want to point out to you is now the value of member of, and here it is. Microsoft Active Directory Management AD Property Value Collection. That is not the name of any group that the administrator account is a member of. It simply says this was the object type that I contained when you saved me to a CSV file, but since I could not save the actual values, I'm simply going to tell you what I was. But again, you can see we do not have any information to tell us what groups that administrator was a member of. Next, we're going to take a look at saving our information in an XML file. An XML file can maintain a hierarchy. It can maintain complex objects with more than 2 dimensions. This allows us to fully recover all of the properties of our object if we save it to disk. Let's take a look at using it. On line 15 and 16, we're going to run the same command for the administrator's user object, but this time we're going to export to an XML file. Now we're going to recover that information with the import CLI XML commandlet. Here you can see that we fully retain the names of all security groups that the administrator account is a member of. We've fully recovered the properties of this object. What we learned in this lesson is that CSV files are really good for storing 2-dimensional data. That is, objects that have properties, but those properties have singular values. This is really good if you want to open up that information in either the Out Grid view or even Excel. However, if you have data that could potentially store or does store complex data, then an XML file is the way to go. This is going to allow you to fully recover that information and continue to use it in the PowerShell pipeline. When I deliver my PowerShell classes, I find out that a lot of IT professionals avoid using complex objects. They do this because they have trouble accessing and they don't understand how to get their information out. To access your information in a complex object, we're going to take a look at using getMember to find out what is inside the object, and then we're going to find out how to extract specific pieces of information using both selectObject and then directly accessing the property. Let's take a look at some code. Here, we're going to save the operating system object into a variable called OS. This will make things a lot easier for us. Now we can take a look at the members of the object from the Win32_operating system class. What I'd like to point out to you is a property called installDate. This property itself is actually containing an entire object, making this a complex object. Let's go ahead and directly access the install date and ask for its property information. We can see that this is a system.datetime object. We can also see that it contains many different properties. What we're going to do is extract out the day of year property value. And here you can see day of year. Using selectObject, we can use the expand property parameter to extract out the value of day of year. Let's go ahead and do that. Here you can see the value is 261. Many of you may be familiar with the property parameter. Let me show you the difference. You notice how there's a column header. The reason for this is the property parameter filtered the other properties out that we saw with getMember, leaving only one property called day of year. When I pipe it to getMember, you can see that we only have day of year left. That is not our intent. We want the value of the day of year property, not an object that has a property called day of year. So to properly do this, we want to make sure we use the expand property parameter, and that extracts out the correct date. You may also like to access the property directly. This is my preferred method. You can see that we are accessing the operating system object. We are directly accessing the installed date property, and then we are directly accessing the day of year property. And in this case, it's going to give us the value. The dots simply represent the hierarchy with the operating system object at the top, and then we're just stepping through each level of the hierarchy. Let's take a look at another example. Here, we're going to be grabbing the user object of the administrator, and we're asking for the member of property to also be included in the output. The member of property is a complex object. We know this because it is surrounded by curly braces. We're going to save this user object into the variable user, and you can see when we ask for it, we get the object. And if we wanted to extract out the value of the member of property, we simply type in $user dot and the next level of the hierarchy, which is member of. And now you can see each group that the administrator is a member of. What we learned in this lesson is what a complex object is. And again, it is an object whose properties contain more than one value. We also learned how to navigate through the object by simply navigating through the properties. We use the period to denote a different level inside the object, and we simply say the name of the property that we want to investigate. We also looked at how to extract values from the object's properties themselves by navigating all the way to the property we want and simply running it, and we get the value out of that property. We're going to take a look at a member of an object that many PowerShell users don't pay a lot of attention to, and these are called methods. Methods are really neat because they are actually software that is built into the object that you can take advantage of. This software is something that you don't have to code. You don't have to debug. You don't have to maintain. It is part of the object and fully available for your use. Let's take a look at an example of a method. We're going to take a look at a string object. I'm going to call up the PS module path, and you can see that it is outputted as a series of strings. This is actually 3 separate strings, or should be, but they're presented as one. Let's take a look at the methods for the string object. First of all, to confirm, we are working with a string. But if we scroll down into the member data, you'll see these methods. And the methods that we're going to implement is called split. Again, the reason why we want to do this is this single line of string is actually 3 separate lines. So what I'm going to do is call the split method. I had to first get the object, the string object, so I executed my variable inside of parentheses, and then I dotted out the split method. I do this the same way I would if this was a property. All methods have a parentheses after them, and if there's any input required by the method, it's inside those parentheses. In this case, split is asking us, what character should I split this string up on? And you can see that we're going to use the semicolon. When I do this, now we have our strings separated so we can read them. Let's take a look at another method. We're going to take a look at getDate, and I'm going to go ahead and send it straight to getMember so we can see the methods that are available to us. At the bottom of the list are our properties. These are what we're used to playing with, but up here are the methods. This is actually a really good example of how to use methods with PowerShell. The datetime object gives us a calendar object, so to speak. We don't have to program in a calendar. Let's say, for example, that we need to modify the current datetime object. Well, if I run just getDate, it gives me the datetime object as it is right now. However, what if I needed the day of week property? Well, I simply put getDate inside of parentheses and dot out the day of week property. You can see that today's Monday. But if we needed to add days or remove days because maybe there's a parameter of another commandlet that requires us to use a datetime object, well, all I have to do is call the addDays member, and I can add 5 days to today. Or I can call a negative number, and I can remove days out of the current date. This is really advantageous to you because let's think about it. Let's say it's January 2nd of 2010. And you actually need to call the records for the past 5 days. That takes you back into December of the previous year. So you would actually have to create a date timestamp that goes back in time. To create an object that understands a calendar is a very complex formula. I've had to do this when I was in college. It's no fun. What you just saw on the screen would have saved me days when I was in college trying to program one of these. Let's actually use one. I'm going to remove 2 days from today's date, and I'm going to save it in a variable called date. Now I'm going to use getEventLog. I'm going to pull events from the system log, but only after 2 days ago. The after parameter requires a datetime object, and that's what we have stored inside of date. And when I run it, you can see that I get the objects going no more than 2 days back from the time that line 22 was executed. We're going to take a look at how to create methods and put them into our PowerShell objects. We're going to look at the add member PowerShell commandlet. We're also going to take a look at the member type called script method. These are methods that are created inside your scripts. We're going to be using the name parameter to provide a name to our method, and then the value parameter to tell it what to do when this method is called. Let's take a look at some code. Here, we're going to go ahead and create a brand new object. This object is only going to have one property. That way we can stay focused on what we're trying to actually accomplish. We're going to simulate some type of a moving object. So I'm going to put this in the memory, and I'm going to go ahead and display that object. It currently has a speed value represented as 0. Let's take a look at the members of this object. You can see that we have our standard default methods provided by PowerShell, and we have our one property. This object's not able to do a whole lot because we can't tell it to start moving. So we're going to add a method. In this case, it's going to be something similar as if we press the accelerator on our car. We're going to call this method accelerate, and then we're going to provide it a value. The value is going to be this object's current speed property will now be equal to whatever it is right now plus 5. The this variable represents the object that this method is a part of, and it can call any property from that object and use it and modify it. I'm going to go ahead and read this into memory. You can see how we're piping our object into add member. Remember, $obj is just a variable that holds a copy of our object. I'm going to go ahead and read this in the memory, and now I'm going to ask for the member data. Here you can see we have our original current speed property, and now we have our method called accelerate. Since our method did not have any input provided to it, we're going to be using an empty set of parentheses. We'll change this in just a few minutes. I'm going to go ahead and call our method. And now let's take a look at the value of the object. You can see that current speed is now 5. If I were to call this again and check it out, you can see it's now 10. That's because we hard-coded 5 as the increase in our speed. Let's add an argument that we get to provide the speed that we're going to increase by. Here we have our object being piped into add member. We're calling the member type parameter, and what we're going to be doing with it is creating a new script method. Now do take note that I'm using the backtick character to try and keep the screen very clean here. The backtick may be difficult to see. On the American keyboard, it is above the tab key, and it allows me, if I press enter right after it, to continue typing on the next line. Here we have the name parameter. We're going to call our method accelerate more. This time we're going to provide a value. Inside the value, we have some similar code. We're calling this object's current speed property, and we're going to set it equal to the current speed property plus a value called amount. Amount is actually a parameter. We're going to pass information into this particular script method. By default, amount is going to be 0, so if you call this method and don't provide it anything, it's not going to accelerate. But this is where we can provide a value to increase our speed. Let's add this method to our object. Let's confirm that is there and accelerate more is present. I'm going to go ahead and accelerate this object by a factor of 50. Remember the current value, let's just check out the current value, is at 10. I'm going to accelerate more. And now I'm going to take a look at the current value of the object, and our current speed is 60. That is what a method allows you to do. It allows you to take some type of action against the object that method is part of. What we learned in this chapter is what a method is. It is simply software that's added to the object that the consumer of the object can call and use. We learned how to not only create methods, but also call the methods. All methods end in parentheses. Even if they do not get a value, they end in an empty parentheses set. We learned how to create methods that do not accept values, and we learned how to create methods that do accept values. You're going to find methods to be very specialized cases. Most of the time, we are dealing with properties. However, as PowerShell continues to evolve, particularly in the PowerShell 5, you're going to find that PowerShell's usage is going to go beyond the ability for us to just manage our environments, and we'll be able to create more applications using PowerShell. One of the new features of PowerShell 5 is for you to describe a class. A class is simply a description of the object that you want to create. So this is going to be a new way for us to create objects. In this lesson, we're going to cover declaration of your PowerShell 5 classes. We're also going to talk about how to create properties and ascribe and use enumerations. And then we're going to use constructors to build our classes. In part 2 of this lesson, we're going to take a look at methods, which allows us to add program code to our objects. We'll take a look at inheritance so we can cut down on the amount of typing that we need to do. And then we'll also take a look at hidden members so we can make sure that we obscure information from the user that we don't want them to see but we still need to use. Let's start off with our declaration. To declare a new PowerShell 5 class, we're going to use the keyword class. We're doing this the same way as if we were using the keyword function or workflow. Class is just simply the keyword to say, hey, I'm declaring a new class. Let's take a look at how to use it. Here we have our first demonstration code. You can see that we're using in line number 3 the keyword class, and the class name will be called vehicle. This vehicle is going to have 2 properties. And in line number 10, you can see how you call a new instance of this object. I'm going to go ahead and read my vehicle class into memory. And then I'm going to ask for a new instance. And you can see we have direction and we have speed. Our properties use variables just as parameters did inside of functions and scripts. However, there is no param blocks. We don't actually declare parameters the way we traditionally have. We just simply provide the parameter name in the form of a variable. We can also cast our properties to be a specific data type. In this instance, we have direction as a property and we have speed as a property. The direction has been typed as string and speed has been typed as integer. You can also see that we provided the default values for each one of these. Let's talk a little bit about enumerators. An enumerator is simply going to be some type of an ordered list of values. You start an enumerator with the enum keyword and then you give it a name. So once again, it's going to kind of look like we're using a function or workflow or a class, but we're declaring an enumeration. We then list the values in their order. Even if your values are string values, you reference them by integer number, with 0 being the first, and then you continue counting. Let's take a look at using an enumeration. Here you can see that we have an enumeration called course. Just like we had a class called vehicle, we're going to use the keyword enum and then give it a name that we're going to refer to it as. Value number 0 is north, value number 1 is northeast, value number 2 is east, and so on and so forth. So we have 8 values, 0 through 7, in this enumeration. Let's go ahead and read the enumeration into memory. If you ever want to see the actual values that are contained inside of an enumeration, in our case, the name of this enumeration is course, here is the code to do so. Simply say, I need to use the enumerator object, run the getNames method, and the argument is course. And you can see it will enumerate in order each value inside that enumeration. Let's go ahead and use this enumeration. Here we have our vehicle class once again. This time, we're going to declare direction as a course. Now, if we go back to our previous code, you can see direction was declared as a string value, and we provided it a string. In this case, we're going to use the course as the data type for our direction, and we're going to give it the integer value of 2. I'm going to go ahead and run this into memory. And now I'm going to ask for a new instance of this object. Remember, north is 0, northeast is 1, and east is 2. When we run this, our vehicle is traveling east. Also, if we pipe this to getMember, you'll see that the data type of direction is course. It is no longer string. Now that we have our vehicle class declared and we can call it and we also have an enumeration, let's take a look at what a constructor is. A constructor is a description of how the object is created. So far, we've used the new method to call a new instance of our vehicle class. When we do that, it accepts the default value of all the properties that we've declared. But we can provide alternate constructors to populate those properties with different values. In order to do a constructor, we're going to provide a constructor name. We're going to provide it a set of parentheses. Those parentheses will contain the arguments that we want to provide to the constructor to alter how the object's built. And if there is any type of coding that needs to be done to make this happen, we're going to have our script block represented by a pair of curly braces. If at any time you need to reference the object you're working with, for example, if you want to change a property value, we have to use the this variable. This represents what I'm working with right now. Let's go ahead and take a look at how to use this. I'm going to go ahead and read our course enumeration into memory. It has not changed. Our vehicle class has not changed with regard to our properties. However, it has changed right here with our constructors. Our first constructor is the default constructor. You call a new instance of vehicle. You do not provide it any arguments whatsoever, so therefore nothing special is done. It will create a new vehicle heading east with a speed of 0. However, if you call new instance of vehicle, and this time you provided a direction and a speed, then this code down here will execute. In this case, it says take the current object that I am working with, modify the direction property with this value, and the same thing for the speed as well. Let's take a look at using this. I'm going to go ahead and read our new vehicle class into memory. I'm going to call a new instance of the object with the default constructor, and you can see our vehicle's heading east with a speed of 0. I'm now going to use our second constructor. Our second constructor required 2 arguments, both of integer value, and you can see 5 and 10. When I call this new instance, I'm heading southwest with a speed of 10. And once again, I can enumerate all constructors of this object, and you can see that I have one where I can describe the direction and the speed. Here's what we've learned. PowerShell v5 is required for you to use this new class method of declaring objects. We learned how to declare a class with the class keyword. We learned that properties are simply variables. These properties are added into the class so that it has information. We have enumerations described with the enum keyword. Enumerations provide you with an ordered list of acceptable values. We also took a look at constructors. Constructors tell PowerShell how to create that object. In creating PowerShell 5 class objects part 2, we're going to take a look at how to build methods, work with inheritance, and hide members from the user. In part 1, we learned how to declare our class objects with the keyword class. We learned about properties so we can describe those objects. We learned how enumerations can provide an ordered list of acceptable values to our properties. And we took a look at how constructors are used to build our objects. Now we're going to go to a little bit more of an advanced level. We're going to start off with methods. Simply put, a method allows an object to act on itself. In other words, you're going to give your object program code. Properties simply describe an object. For example, if we had a cell phone and we had an object called color, whatever color your cell phone happens to be, that's the value. But with methods, it's actual program code. Let's go ahead and use some methods. Here we have our original code from part 1 of this lesson. I'm going to go ahead and read in our course enumeration. And now I'm going to take a look at my class called vehicle. We left off with 2 constructors, the default constructor, and also one that describes the direction and speed. We had 2 properties, the direction and the speed. But now we have methods. In this case, I have methods that change the direction of our ship. Starboard is to the right and port is to the left. We had to put some code in here because let's say we're traveling in a northwest direction and we turn to starboard, which is right. Well, we would normally increment this enumeration by 1, but there is no value of 8, so we need to make sure it goes to a value of 0. And if we're going to turn left and we're currently traveling north, we need to make sure we change the value to a 7. That is all that this code does. is ensure that those activities happen. You could see we still use the this variable to reference the current object I am working on. If its direction is equal to the value of 7, then change the direction of this object to 0. However, if the direction of this object is not 7, go ahead and increment it. That's all this code says. Let's go ahead and read this in the memory and see what happens. I'm first going to ask for a new instance of our ship. I'm going to save it into a variable called ship so we can easily reference it and use it. Let's take a look at the current value of ship. You could see we have a ship, it's traveling east with a speed of 0. I'm going to invoke the turn starboard method. Because we did not provide any arguments to turn starboard method, we simply leave a blank parameter block. And now let's take a look at the ship's object, and you can see we have turned to the right. We have gone from east to southeast. Let's take a look at inheritance from this perspective. I have a set of objects that I need to make. Let's say that all of these objects are some type of a car. Every car that we're going to make is going to have tires, doors, windows, and some type of a color. But from there, each of these different cars will have unique features that the other ones do not have. So instead of programming these same base properties over and over again, we're going to create it only once, and then we're going to make a reference to those objects for each new one we create. Let's take a look at how to use inheritance with PowerShell. Here we have our same code. I'm going to read our enumeration into memory, and I'm going to read our vehicle class into memory. It has not changed. You can see we have the same properties and the same methods. This is now where it's going to change. I'm going to make two ships. We're going to create two of them. We're going to create a destroyer, and we're going to create a carrier. This time, what I want to point out to you is what is happening at the end right here. Colon, and then the base class. What this is saying is take every property and every method of vehicle and apply it to this new class called destroyer, and then on top of that, add my properties and methods. We're going to have a constructor called destroyer. We'll either use the default constructor to make a destroyer, or we can give it a name when we build it. We're also going to give it two unique properties. Sonar on is going to be a Boolean value. We're going to set it to false. And we're also going to describe the number of torpedoes and give it an initial value of 50. We'll also provide it with two methods, turn sonar on and turn sonar off. Let's go ahead and read this in the memory. Our next vehicle will be a carrier. Once again, it will inherit the base class vehicle. We'll have constructors and, of course, unique properties, the number of aircraft that are currently on the ship and the maximum number of aircraft that the ship can handle. We're also going to give it two unique methods, the ability to launch a specified number of aircraft and the ability to recover a specified number of aircraft. I'm also putting in a couple of warning messages. For example, if you try to launch more aircraft than what you have, you will receive a message, not enough aircraft. And if you try to recover more aircraft than what you have room for, too many aircraft on board will be your warning message. We will see these. Let's go ahead and read the carrier class into memory. I'm going to go ahead and create two new ships. Ship A and Ship B will be the variables that hold our two different ships. We're going to create a destroyer, the USS Zumwalt, and a carrier, USS Ford. Let's take a look at the value of these two ships. I can see I have the Zumwalt. Now remember, we gave it its own unique properties of sonar on and number of torpedoes, but the name, speed, and direction all came from the base class vehicle. If we take a look at Ship B, we gave our carrier number of aircraft and max aircraft, but name, speed, and direction all came from the base class vehicle. If we take a look at their member information, I can see that the destroyer has number of torpedoes and sonar on as part of its members, and Ship B has max aircraft and number of aircraft as its members. You'll notice that neither one of these share their specific members. Let's go ahead and make sure that our inherited members still work. So we're going to turn Ship A and Ship B in two different directions, and we're going to see their values. And I can see originally both are heading east. Now the Zumwalt is heading southeast, and the Ford is heading northeast. So the inherited methods still work. Let's test the unique methods that each class has. For our destroyer, I can see that the sonar is currently turned off. Let's invoke the turn on sonar method and check the status. I can see that the sonar is currently turned on. As for our aircraft carrier, the current number of aircraft on board is 85. I'm going to go ahead and attempt to recover 5 more aircraft, and I cannot do that. Too many aircraft on board. So I also know my unique methods for the carrier class is working. There are going to be some instances when you don't want the user to have easy access to the properties or methods that are inside of one of your class objects. And we can use the hidden keyword to hide this information from your users. Now remember, they can still pull that information if they knew how, but through our normal mechanisms of discovering the members of an object, they will not be available. Let's go ahead and look at using the hidden keyword. We're starting off once again with the same code we had earlier. So I'm going to read our enumeration in the memory, and I'm going to read our vehicle class in the memory. And now let's take a look at destroyer. I did make a slight change to destroyer, and that's right here with the hidden keyword. What the hidden keyword is going to say is, do not show the number of torpedoes that I currently have. Obviously, if you have an adversary, you do not want them to know how much armament that you have. So we're going to hide that. Everything else in the destroyer is the same. On the carrier class, I do not want anybody to know how many aircraft that I have. It's common knowledge as to how many aircraft a U.S. carrier can hold, but how many they actually have on board, we probably don't want people to know that. So we're going to put the hidden keyword on number of aircraft. Everything else in the carrier class is the same as before. We're going to create our same 2 ships as we did before, and let's take a look at their status. You'll notice that on the destroyer, sonar on is being shown. However, you might notice that the number of torpedoes are not. On the carrier, the max aircraft is available, but the current number of aircraft is not. Let's take a look at their member information. Piping ship A to get member, I cannot see the number of torpedoes. Piping ship B to get member, I cannot see the number of aircraft. I can still use my methods. I'm going to turn each ship and check their status. And you can see they're heading in different directions now. I'm going to go ahead and launch 10 aircraft and check the status. And I can see that the max aircraft is currently at 85, but I still can't see the number of aircraft that are on board. That value is hidden. However, the object knows what its current value is. Now that we have our aircraft launch, let's go ahead and take a look at the object for the aircraft carrier. And it still does not display the number of aircraft that it currently has, but it does know. We know the maximum number of aircraft it can handle is 85. We're going to try and recover 20 aircraft. That's 10 more than what this aircraft carrier can handle. And the method works, warning too many aircraft on board. The number of aircraft property is still there. You can ask for it specifically if you know it. Even though when we pipe ship B to get member, we could not see the number of aircraft property, but if you ask for it explicitly, it will give it to you. As a matter of fact, if you use the force parameter on each one of these objects, you will see the hidden members. So for ship A, I can see the number of torpedoes, and ship B, I can see the number of aircraft. In this lesson, we learned about methods. Methods allow us to put code inside of our objects. That code can act on the object and do different things. In our case, we turned our ship, we turned the sonars on and off. We learned about inheritance. Inheritance can greatly reduce the amount of typing you need to do, but also help you update your objects. With inheritance, you're going to create a base class. All the methods and properties of that base class will become part of the methods and properties of any class that derives whatever that base is. So in other words, if you have a car and you say all cars will have tires, and then you create a secondary class that inherits the base class, that secondary class will have tires, even if you didn't program it in explicitly. We also learned about hidden members. We learned how we can hide properties and methods from the user when they pipe an object to get member. We saw that they can explicitly ask for those hidden members if they wanted to, but through our normal methods, those properties and methods are hidden from the user. The PowerShell pipeline is one of the key features of Windows PowerShell. In this lesson, we're going to take a look at an overview of the PowerShell pipeline to give you a better understanding as to why we use it. First off, the PowerShell pipeline is a series of commands that are typed together. The output of one command is going to be the sole input of another command. Another thing to realize is that if command 1 produces multiple objects, only one object will pass through the PowerShell pipeline at any one time. Command 1 will not send the next object until the first object has exited the pipeline. Some of the advantages we're going to gain with using the PowerShell pipeline is that it will greatly reduce your coding. I've actually taken the time to write code traditionally and in the pipeline. The result is the pipeline is much faster and easier to code. It also gives us a better interface with Windows and Microsoft software as a whole, because with the pipeline we're using objects and everything that comes out of Microsoft software is presented as objects. It also gives us consistency. The way how we interact with objects is going to be the same no matter where that object came from. Let's take a look at some code. Line number 4 is our starting commandlet. This will produce drive objects and put them into the PowerShell pipeline. Now let's say we want to only have drives of drive type 3. Well, what we can do is pipe it to another commandlet. So here is the PowerShell pipe character. It is the vertical key above the enter key on the US keyboards. Here we're going to pipe it to the commandlet whereObject. So the only input going into whereObject is the 4 objects produced by the first commandlet. And you can see that we've successfully filtered for drive type 3. Another thing to take note of is that the pipe character is a line continuation statement. It allowed me to place whereObject on line 8, but it's still interpreted as if it's part of line 7. In other words, I could have written it like this. The line continuation allows us to prevent us from horizontally scrolling off the screen. In this next series of code, you can see that we are building on what we've already done. We have our 2 objects that were filtered out, and now we're going to pipe them to select object. Since we're still working with objects, we can do that. In this scenario, we're going to add an extra property using a hash table with select object. If you look at the help file for select object, example number 4 gives you an example of how to do this. A key element that I would like to point out is the usage of $_. You see, when we're working with an object in the pipeline, remember there is only one object in the pipeline, and we need to reference it. So $_ is an automatic variable that is created to do that. It has access to all the properties and methods of the current object in the PowerShell pipeline. When I run this code, you can see the results. Free space is now represented in gigabytes. $_ was used with PowerShell version 2. From 3 on up, PSItem can also be utilized as the generic variable if it makes more sense to you. Another thing to take note of is that there is a hidden pipe at the end of every PowerShell commandlet. Let's take a look at line number 18. It produces BIOS information. Here I'm piping the commandlet to outDefault. Now remember, outDefault is the commandlet that is normally at the end of a PowerShell pipeline by default, and you can see that the output has not changed any. Here there's no change in the default output because outDefault is always implied. This is just simply to show you what it would be if you explicitly put outDefault in. Some commandlets do not place any objects into the PowerShell pipeline, so therefore nothing will appear on the screen. In this case, when I run getCIM instance against Win32_BIOS, I piped it to export CSV. Every object was put into a data file, which meant nothing was left in the PowerShell pipeline, and that's why nothing appears on the screen. So what we've learned in this overview is just a basic look at what the PowerShell pipeline is. We also took a look at how objects move through the pipeline and how you can reference their properties using $_ or $PSItem as a variable that contains that one object that's currently in the PowerShell pipeline. We also saw that that generic variable also has access to all the properties and methods of that object inside the pipeline. And again, remember, only one object is going to be in the pipeline at any one time, so you always know that you're going to treat each and every object with equal opportunity. The PowerShell pipeline is a key feature of PowerShell that's going to greatly reduce the amount of coding that you need to do. We're going to take a look at one of the 2 methods to use the PowerShell pipeline. This is called ByValue. With ByValue, PowerShell will look at the actual value of the object that you're passing through the pipeline. For example, if you pass the number 1, it is actually going to look at the number 1. The receiving commandlet must have a parameter that accepts information by value from the PowerShell pipeline. It must also accept the same .NET type as the data being passed. Since the number 1 is an integer, the parameter must accept integer values or be able to convert to an integer value. Also, we need to make sure that the parameter is not currently in use. Let's take a look at some code. Let's first take a look at a couple of lines of the help file about pipelines. This section of the help file simply reiterates what we need to accomplish before we can pass information by value. And again, we're looking at the parameters of the commandlet that we're passing information to. It must accept information by value, must have the same .NET type as the incoming information, and we cannot be explicitly using that parameter when we actually pass information to the commandlet. We're going to be looking at test path. Now, these 4 lines actually show you the information that we need in order to determine whether or not the path parameter accepts information by value from the PowerShell pipeline. I'm going to use line number 10 to take us directly to where we need to go. We can see that, yes, true, it does in fact accept information from the PowerShell pipeline by value, and the data type is string. I included a couple of other methods to determine both the data type required and whether or not this commandlet on this parameter accepts information from the pipeline by value. Let's give this a try. You can see that we're passing the string C: the test path. Test path will return a true if this path is found, or false if it is not. You can see that we return true. In the next line of code, we're going to pass several strings to this parameter. We can see from the help file that we can in fact pass multiple values to this parameter because of the square braces. The square braces tells us that this particular parameter accepts multiple pieces of information. I also want to point out that one of these paths is incorrect. It does not exist. So let's see what happens. I'm going to go ahead and run line number 18. True, true, false, true. The third item, which we knew was bad, returned false. So this is working. We are passing by value to the commandlet test path, and its path parameter is accepting that information. Now I want to show you what happens when we're passing information to a parameter of a commandlet, but we're also using that parameter. This will fail. Remember, we cannot pass information to that parameter and explicitly call it. As a matter of fact, when I type in test path and look for its parameters, you will see path is there. Now, when I pipe something to it in the PowerShell ISC, and I'm going to ask for its parameters, path is not there. The ISC filters it out because you cannot use it because you're passing information to it. What we learned in this lesson is how to read the PowerShell help files for pipeline input. Remember, the full help file, show window, online, or going straight to the parameter that you're interested in will show you the extra metadata that tells you true or false, will I accept information from the pipeline. We learned what by value means, and that means the actual value of the object will be evaluated. And we also learned how to pipe information by value through the PowerShell pipeline to a commandlet. The PowerShell pipeline is a feature that's going to greatly reduce the amount of coding that you have to do. There are 2 methods to use in the PowerShell pipeline. In this lesson, we're going to take a look at using it by property name. When we pass information from one commandlet or object to another commandlet, we are looking to pass information to the receiving commandlet's parameters. There are 3 requirements that we must have in order for this to work. First off, the object that we are passing into the receiving commandlet must have properties whose names match the names of the parameters of the receiving commandlet. Those parameters must accept information from the PowerShell pipeline by property name, and the .NET types of both the properties and the parameters must match. In other words, if you're trying to pass information to a parameter that only accepts integer values, the object must have a property by the same name of that parameter, and the data contained inside of that object must be an integer. We can also not be explicitly using that parameter when we are passing information to it. Let's take a look at some code. Here in our code, we're going to take a look at a couple of lines of the help file about pipelines. This simply explains what by property name means. If we take a look at the help file for the next several sections here, we're going to see that we're looking at the commandlet new AD user. This is the commandlet that we're going to send information into. But we need to make sure that we have parameters that accept information from the PowerShell pipeline. So I've selected a few here. The name parameter does accept information from the PowerShell pipeline by property name if the incoming object has a property called name that contains string data. Now, take note here that this parameter only accepts a single value. It does not accept multiple values. This will come into play a little bit later on. If we take a look at the help files for the given name, the surname, the city, and the office, all of them are identical. They accept information by property name. What we're going to do in this next section is create a CSV file. This CSV file will be used to create new user accounts. I'm going to select this entire block and press F8 to run it. And now I'm going to import that information in so we can see the objects that we received. Here you can see 3 objects. Each one of them has a property called name, given name, surname, city, and office. We know those 5 property names can be accepted by new AD user. Let's go ahead and create our first one. Now remember, we cannot send multiple objects to new AD user because its parameters are not designed to accept them. So we're going to grab the first object, which is going to be Patrick Miller, and use that to create our new user account. There we go. Let's go ahead and verify Patrick was created. And we can see Patrick was created, and our city and office fields, along with our given name, name, and surname fields, all populated and became part of the user's object. I'm going to remove Patrick's account from the system so we can play with this demonstration a little further. If you remember, when we looked at the help information for each of those parameters, they would not accept multiple values. So if I were to pipe the entire CSV file to new AD user, only Patrick would be created. The rest would error out. So to trick PowerShell into allowing us to do this, we are going to import our CSV file just as we did before, but we're going to send it to for each object. Inside for each object, since we're using the PowerShell pipeline, there is an automatic variable called $_. For each object will execute 3 times. The first time it runs, $_ will contain the object information for Patrick, the second time for Stan, and a third time for Mike. In the end, we will get all 3 user accounts created. Let's go ahead and run this code. There we go. And let's verify the creation of those accounts. And I can see that we've correctly created all 3 accounts. What we learned here is how to discover inside of the PowerShell help files how to determine which parameters accept information from the PowerShell pipeline and by property name. We discovered what by property name means, and that simply means that if you have an object with a property that happens to be named the same as the receiving commandlet's parameters and their data types are the same, then we can pipe information to it. And then we also looked at 2 ways to pipe information by property name to a commandlet. PowerShell has the capability for you to create functions that act just like commandlets in the PowerShell pipeline. You'll hear them referred to either as filtering functions or advanced functions. A filtering function allows you to pipe information into it. That means you can use it in the PowerShell pipeline. It will be treated just like any other commandlet inside of PowerShell. You can pipe information into it, and it'll put objects into the pipeline so that that information can be piped to another commandlet if needed. In order for us to have filtering functions, I'm going to introduce you to 3 new keywords. First of all, we have begin. Anything that's inside the begin block will run before any processing of objects take place. So it's only going to run once. This is a good place for you to set up any support functions or variables that'll be used inside this commandlet. The second area is the process block. Inside a process, each object will be processed. That means no matter how many objects get sent in, process will execute once per object. The final area is the end block. The end block will only execute once. It will execute when there are no more objects coming through the PowerShell pipeline. This is a good area for you to close up any loose ends, close database connections, delete temporary files, anything you need to do to clean up what has happened inside of that particular commandlet after all the objects have been processed. Let's go ahead and start taking a look at some code. This is a very basic filtering function. You can see we use the function keyword to declare it. I'm using some type of a verb-noun. I'm just calling this my command just for this example. You can see that we have turned on commandlet binding and we have at least an empty parameter block. This allows this particular commandlet to take advantage of the common parameters, but also PowerShell will treat it as if it's a commandlet. You can see our begin, process, and end areas. In code 2, I expanded those areas out and I just left some notes. Again, the begin area will run once before the first object is piped to it. Process will run each time an object is piped to it. And the end block runs once after the last object is piped to it. In filtering functions code 3, I've made some modifications that will allow us to pipe by value the name of a computer to be processed. A few things I'd like to point out to you. First off, right here is a help file. The help file will show you how to structure your parameters to accept information from the PowerShell pipeline. Here I have a variable called computer name, and it is set up to receive information by value from the PowerShell pipeline. In our begin block, I am using write host just to display to the screen that the first object has come in. Process, you'll see we'll get the BIOS information for each computer sent to this commandlet. And then finally in the end block, I'm once again using write host just to let you know that the end block has processed. I'm going to go ahead and read this information in the memory by running the script. And now I'm going to go ahead and send the value of DC, which is the name of one of our computers, to my command. And we can see the results. First object in was created by the begin block. You can see the process block has executed, and then the end block tells us the last object is out. Let's try that command again, but this time I am going to send to it the name of 4 computers. Now, 2 of these machines are actually online, so I'm just going to repeat them, but you'll see the end result. And we execute. So let's go to the begin block is executed. Here's for the first DC, SVR1, DC, SVR1. So the process block has executed 4 times, and then the end block is executed with last object out. Now again, this is passing information by value. And again, you can see the values were string values. That is one way of using the PowerShell pipeline. The other way of using it is to do it by property value. In code 4, we're going to set up a CSV file to help us with our demonstration on piping information by property name. We're going to create a CSV file. This CSV file will have 2 objects created, each with 3 properties, a computer name, a description, and a location property. Let's go ahead and execute this code, and let's take a look at the end result. And you can see we have 2 objects with a computer name, description, and a location field. Let's go to filtering functions code 5, and let's look at some changes that were made. Now, each one of our parameters have been declared. We have a computer name, a description, and a location. Each one has been set to receive information from the PowerShell pipeline by property name. If we scroll down to the process area, you'll see that we're going to make a modification to each computer. We're going to modify its location and also its description. I retained the first object in and last object out in both the begin and the end block, so you can see those executing. Let's go ahead and run this into memory. So I'm going to select just my command and run F8. Now if I scroll down below the function, I will see some commands I'm going to execute. This first one is going to show us the current status of the location and the description fields, both DC and SVR1. Remember, we have not executed the command yet that's going to make the modifications. You can see both location and description properties are empty. I'm going to go ahead and execute the command. Here we're going to be importing that CSV file, and then we're going to pipe it directly to my command. You can see the first object in and last object out did execute. Because we did not place anything in the PowerShell pipeline in the process block, no information was displayed. Let's go ahead and look at the current values of the location and description properties for those computer objects, and you can see that they have been modified. Now, this code accepts information from the PowerShell pipeline, but what if I wanted to provide it a list of computer names, in other words, by value, but then also explicitly change the location and the description fields? That's where filtering functions code 6 is going to give you an example of how to do this. Modifications that I made to the code, I placed back in the ability for the computer name parameter to accept information by value from the PowerShell pipeline, but I also retained its ability to do so by property name in case we wanted to pipe objects to it. In the process block, an additional modification was made. In the process block, I used a for each loop. Because I may be sending information to this particular parameter, which is computer name by value, I need a way to loop through multiple values if I choose that path. Line 37 is the same line of code as what we used before, except I changed computer name to name, so it'll be placed inside the name variable. Let's go ahead and run this code into memory. And now let's take a look at piping information by value and changing the location in the description field. Now remember, just a few minutes ago, we were piping information in from a CSV value, so we were doing the pipeline by property name. Now we're doing it by value for multiple values. We're going to check the new values, and we can see that the location and the description has been changed. What we learned in this lesson is what a filtering function is. It is a piece of code that allows you to pipe information into it. We learned how to pipe by value and by property name, but then we took it an extra step just in case you need to pipe information to one of your parameters, both by value and by property name.